Good morning, everyone. How's it going?
Good morning.
Whew.
Morning, everybody.
Morning, Connor.
Morning.
We have just a few minutes for everybody to come on in. Where are most of you located at, actually? Are you scattered all over the
All over the
States?
place, yeah. All over
Yeah.
the place.
Awesome.
Many in Chicago, but then it's people in New York, Connecticut, Colorado, I'm gonna say.
Wait, what was the last one, David?
Colorado.
Colorado.
Oh, Colorado.
Ohio.
Connor, no, it's not.
What's that?
Did you say that's where you're at?
No, I said Montreal.
Oh,
Shouting
Oh.
out, yeah, our Canadian friends.
Yeah. WebAge is headquartered in Toronto, but they've got offices all over technically, I guess it's the world, but mainly in the continental United States and in Canada. So obviously I'm in Atlanta, in hot Atlanta, which is quickly becoming hot Atlanta. So good. So then people scatter all over. It's good you have a distributed team. I find I imagine you have been this way for years, if I were to speculate. Finding more and more teams that were already distributed or weathering the kind of changes around COVID and whatnot way better because they were already distributed, so it didn't really matter. So finding some of the more conservative organizations, because I do a lot of digital transformation work, because I used to work for ThoughtWorks as their lead digital transformation specialist. And all that means is just, trying to modernize both the people, processes, and the technology to a certain degree, whatever degree they're interested in. And man, some of the companies are so incredibly conservative. We were working for a parts distribution manufacturer, like a Fortune 50 company, and they were like, "Well, we don't really think that work happens unless you can really just put eyes on everybody, and they have to be in the same physical location." I was like, I think you guys are going to have a tough time, actually. This is pre-COVID. Actually, it was mid-COVID. Actually, it was 2020 when I was talking to them about this. So it's good to hear you guys are distributed all over.
Hard to make mid-COVID, right? You don't really have an option, right?
Yeah. Well, though, some people though look at it as a temporary measure, and so that things are going to go back to the way that they were. And I don't even know what that means actually anymore. I don't think it's going to snap back to where it was. I think you're going to see an evolution. I think there'll be some rebound, but for the most part, you're going to see it just continue to evolve, the nature of work. So, although I have to say, I'm excited. Well, it really would be nice to actually see like better systems for how we can collaborate with each other. So to a certain degree, virtual reality starts to kind of be a little bit more appealing because there's a little bit more of a physical sense of interaction when you are kind of in like a virtual meeting room. I have an Oculus Rift 2 that I got for Christmas, and I've had meetings with the entire family with our avatars and like virtual meeting spaces. Man, it makes collaboration so much better, especially when you can like draw on like a virtual whiteboard and pull objects in and give people like visual representation while you're interacting with people. Plus, the water cooler happens a lot more, because that's actually where all the social capital is created, is in those moments in between the meetings where, like we're talking about how things are going in people's lives, and you get all these little tidbits about what people are interested in, So
David, should we pick up our Oculus next week in the office, or can we get him shipped to home?
So sorry, David, if I set that up. I apologize. Any comments made by me create no obligation with David.
I've got a friend who works at Accenture, and his roommate, I think, like just threw on his Oculus and was just checking it out. He was walking around the Accenture office, and like people are asking him like, "Hey, how's it going, man?" And he's like, "Oh no, I don't work here. I'm just checking it out." Probably not according to policy, but thought it was
Yeah.
fun nonetheless.
Yeah, you that kind of thing really has to be at least group or team adopted, not and then slowly rolled out. So you can't really massively disrupt an entire organization because that means the work gets disrupted as well. All right, so since we're now 6 minutes in, I do want to just talk about this concept briefly. I can't remember who asked me. Maybe it might have been Kyle, but I could be misremembering. Someone was asking me, like, is there like a playground where we can go and get access? And I think some of you mentioned, like, you know, A Cloud Guru has like playgrounds and stuff like that. Again, I still stand by the answer of like the free tier is probably the best way to getting your own account and managing it. You understanding how billing and managing your own account is only going to help the company, even if you have somebody else who does that, because every design decision you make inside of AWS is going to have a security or a billing implication or both. But one thing I want to mention is that I'm actually at a URL called amazon.quicklabs.com. This is not the same as webage.quicklabs.com. So just to be clear, this is the public side of AWS, QuickLabs. Now, this URL is hidden. If you go to www.quicklabs.com, you will not see the content that I'm about to show you. I don't know why that is. Speculatively, even though QuickLabs had nothing to do with Google back in 2016, Google bought them from underneath Amazon. Bought them underneath Amazon in 2016, which we thought was hilarious. We were like, Google, why would you do that? They have nothing to do with Google. Now, if you go to www.quicklabs.com, it's nothing but Google, nothing but Google Cloud Labs. But if you go to amazon.quicklabs.com, there's this hidden public side to QuickLabs, and their catalog contains every single, there's like, I want to say there's like 100 and something. Actually, let's be clear. There's 143. Some of these are quests, so that's not super accurate. There's about 120, 130 AWS labs that are structured in the same way that you've been doing the labs over on the like AWS private side of things. There's an AWS public side of things. It's a different login. So you have to create a new login to get this to work. But what this is that all the stuff like around, and let's exclude all the quests. So let's switch this out really quick. Let's just stick with the labs. So we take all the quests out because the quests are just collections of labs. Practically everything is out here. So for example, if you're like, well, I don't really understand RDS, which is what we covered yesterday. You know, obviously you did a little bit of an RDS lab, but what if you wanted more? Like, what if you wanted more like kind of structured exposure to RDS? There's a public side to this. You can sign up for it and you have to pay $1 per credit. Some of these labs are free. Some of them are 10 credits, 8 credits. You can also just pay $55 a month to get access to them on an unlimited basis. If you do that, I just want to say this. If you pay the $55 fee, please create a schedule of the labs that you're going to do, hammer at the site, and then let the subscription go. Don't just pay $55 a month just to sit on it. That's not going to help you. Have a plan if you're going to do the subscription. If you're not going to do the subscription, just buy a few credits. Do you know that the credits do expire, I want to say every year? At one point they had reduced it to 6 months, but I think it's every year now. So like for an example, if like you have never touched DynamoDB, I don't know that we have a lab on that inside the architecting course. There are more DynamoDB labs here that will teach you about sizing, performance, deploying serverless web apps using DynamoDB. There's tons of really great labs here. You know, again, some of them will cost you, $10 to run, but they're rich. I mean, these are 3 hours of advanced labs. They're totally worth it, and they work. So everything from like triggering streams and whatnot. I think there's like a lab out here. There's at least one lab on EMR. So if you're doing a MapReduce, there's, Amazon EMR, using EMR, big data with Hadoop. Redshift is out here. the point being is that keep this URL in your back pocket, because if you want more structured labs and you don't want the free form workshops that I'm going to share with you at the end, this is available. You do actually need to go and take a look at the pricing, but again, like you could drop $20 down, or you could buy a subscription. Oh, I'm sorry. Did I say $55? Remember I said all the numbers that I say are probably lies. I guess I changed it. It's now $30. Huh, who knew? So just know that those are options. And of course, again, you can always buy individual credits. So if you want to buy 15 credits, you can. Okay. So there's a lot out here. I'm going to forewarn you that there's not a lot out here at the like super like professional or the specialty level, but things like an example of like CloudWatch. There's about a bunch out here for CloudWatch events, creating chatbots with CloudWatch. Like there's all kinds of good stuff. Some items around security, like auditing, right? How to mess with security groups, how to use trusted advisor, how to automatically modify security groups based on a Lambda function you created. So for example, you can actually set up AWS config. If config sees that someone pops up a security group that is wide open to the world, you can create a rule that the minute that happens, a Lambda function will go in, will lock that security group down, and then send an email and say, hey, by the way, someone just tried to wide open a security group. Is that heavy-handed? It depends on your policy. My point being is that it will teach you how to automate AWS in response to certain events, like opening up an S3 bucket to the world that you don't want, right? You can immediately lock it down and then send an email, a notification, say, hey, this is what happened. So just know that this option exists out there. I just want to make sure that whoever asked that question had a more thorough answer for other AWS playgrounds that you could play with. Okay. Any questions about that?
No, that's awesome. Thank you.
Yeah, good. Hope that's useful. All right. So ostensibly, I could fix that. I can just switch my primaries. Yesterday we covered storage and we covered database services. We had a lab for database services. We are totally on track, by the way. Today we're going to do monitoring and scaling, and then we're going to do automation, containers, and we're going to get to networking. So notice that today we're going to have a lab first thing in the morning, and then the rest of it's going to be a lecture. So apologize for that setup. This was just kind of the way it rolled out. We might get to serverless. It just depends. The next kind of like lectures tend to get shorter. EC2 compute is the longest, so they tend to get a little shorter from this point forward. So they start to go a little quicker. And so that's what we're going to be doing today. Is we're going to be doing pretty much those top four squares of monitoring, automation, containers, and then networking too. And then we'll finish up tomorrow morning with serverless and edge services. Little short lecture on backup and recovery. And then I'm going to talk about training and do some resourcing. And then you're going to end with a capstone lab. And the reason I end with the capstone lab is that that's a 3-hour lab. But if you do it in an hour, you're done for the day. So otherwise, if you need the entire 3 hours, I will be with you all the way up until 5:30. But just know that you've got options, right? As we get to that last day. Before we do that, I wanted to take some time to maybe just cover maybe not the full set of questions, but some of the questions that we would cover for storage and for RDS. So let's go take a look at some practice exams and shake the rust off first thing in the morning. So we'll do a couple of EBS questions, a couple of EFS questions, and then we will do a couple of RDS. Notice that they don't really have their own DynamoDB section kind of rolled in there. So let's just do a few EBS and a few EFS questions, and we'll roll to RDS. Okay. As usual, I'll do like analysis for like the first one, and then from this point forward, After that, I'm just going to let you read the question and figure it out on your own. So same center applies, A, B, C, or D for the slots. Okay. So we've got an application consisting of multiple EC2 instances. They're in private subnets in different availability zones. So different subnets, privates. Application uses a single NAT gateway for downloading software patches from the internet to the instances. So there's a requirement to protect the application from a single point of failure when the NAT gateway encounters a failure or if its availability zone goes down. What do you need to add to make it more highly available and cost effective? So those are the two requirements of the question. So take a look and post your answer. Oops. David and Rakesh, I'm going to interpret that as a B. Just to avoid any squishiness, right? Good. All right. So let's check it out. A lot of people are leaning towards B, so let's find out. Okay. Okay, so remember I mentioned is that when you have similar answers, typically, not always, the answer is inside the similar answers. But let me ask you this, why are C and D off the table? What, as far as our requirements to be highly available and cost effective, what does C and D have in it that takes them off the table immediately?
Excessive NAT gateways.
That was well said, actually, Dave. Excessive NAT gateways, right? Yeah, so these are out. Actually, let's use a different color for that. So these are out because they've got excessive NAT gateways. We're not doing that. That's not cost effective. Okay, so this looks the same. We're going to do one in each availability zone. This looks the same, right? But then what was the distinction, right? It was between the public subnet and the private subnet, right? But someone, yes, I think asked a really poignant question yesterday. They said, just to make sure my understanding is correct, really the only difference between a public and a private subnet is the routing table, right? The routing table, whether it's pointing towards a NAT gateway or not, or to the internet gateway. So obviously you saw the distinction is that it was really between these two pieces, right? And so obviously private's it because we want the private subnet to know that it needs to talk to the NAT gateway on the public subnets to get over to the internet. So good. I'm assuming, by the way, that you're going to interrupt me at any time if that does not make sense to you. Okay. Although that diagram is pretty confusing. Anyway, moving on. Oh, by the way, one thing as far as language goes, if they say a NAT gateway instance versus the NAT gateway or NAT gateway service, if they say a NAT gateway instance, they're talking about you rolling your own NAT gateway, which is what we used to have to do. Is that even proper grammar? It's what we used to do when before they actually came out with the NAT gateway service. So just know that if they say NAT gateway instance, they are inferring that you're rolling your own. So beware. Hi, Dave. Uh-oh.
We're all Dave right now.
Okay.
I think Breeze, I used your Zoom link that you posted in our Slack channel. Is that maybe why? Did it like log me in as you?
Yeah, the URL is unique to the person.
That's exactly right.
You can just
Um,
rename. You can just rename yourself. You don't have to log out. Just rename. Just right click on your thing and participant and choose rename.
Oh, okay, cool.
Yeah.
Thank you.
It's all good. Okay, so this one I'm just gonna let you read. I'm not gonna analyze the question in any way, shape, or form. Just A, B, C, or D when you're ready. Good. I'm seeing a lot of B's here as far as provisioned IOPS. Let's check it out. All right, so here's the question for you. What was it that made you certain that it needed to be provisioned IOPS versus, let's just say, general purpose? Because you probably knew that SC1 and ST1 were off the table because those are really cold. Those are colder storage options, right? What made it so that provisioned IOPS was definitely the option? What did I say about provisioned IOPS? What was the clear use case for provisioned IOPS? Right, but good. So I'm glad I asked this question. Let me be super clear about this. A high throughput, right? Although the small random IO doesn't actually hurt for a database. So don't get me wrong. There are probably questions where if it says high throughput, small random IO, it may not say database. So just to say this, it really is for a high throughput workloads involving a database. That's when they really push provisioned IOPS as the answer. So this just cements it. It's a database with a high throughput workload. That means provisioned IOPS from AWS's viewpoint is going to be the answer every time. Now, is that in the real world going to be the answer every time? What do you mean by high throughput? If you're not eclipsing 16,000 IO per second, well, it does say GP2. GP3 would handle that fine. GP2 would as well, but you'd have to up the size on it. Regardless, it's a high throughput database. Provision IOPS is going to be your friend. It's the answer. Again, from AWS's perspective. Also, they'll say things like small random and they'll say SSDs, but I just want to say this. In the real world, the SSDs will handle large sequential workloads better, if not the same as a mechanical hard drive. So this still doesn't work. I will say that you could step down to the ST1 if it is a large sequential streaming workload. Nobody I know in practice has actually done that. But just know the way AWS thinks about it, if it says the most cost-effective option and it says a large sequential streaming workload, they want you to choose ST1. In the real world, you're probably still going to be using GP2 or GP3, just FYI. It's not going to be worth the cost savings, which is not going to be actually that large compared to your ability to handle any kind of random spikes in IO that happen on that system when it's not streaming sequential workloads. So. You do want to take some time to just get familiar with this chart. I don't know that you need to memorize every single thing here, except for the IOPS, the maximum volume size. And then you probably want to be comfortable with the, the general max throughput, because that will also give you guidance about these options. This needs to be updated because I think this is old, and it is actually, because that needs GP3 and IO2 have increased max throughput. So, okay. Last one for EBS. So let's you read this one. Okay. So people put A here, right? And that is the cheapest option for large sequential IO operations. Notice it said infrequently accessed data. If it said streaming, C would be the right answer, right? But notice this is infrequently accessed data. It says nothing about streaming. It's mainly for a data warehouse. It's infrequently accessed, and it's doing large sequential IO operations. So make sure you contextualize all parts of the question. Don't instantly think just because it says large sequential IO that immediately we're talking about ST1. Most of the time we are talking about ST1, but this is cold data that's just sitting there and it's infrequently accessed. So you got to pay attention to what the requirements are, right? To make those distinctions. So cold hard drive fits here. But if anywhere in that sentence it said we're streaming video files, doing sequential operations, you'd have to use throughput optimized. Cold's not going to cut it. So good. All right. Let's switch over to some EFS based questions. All right, we'll analyze this one. So data analytics company, it's got a building a next generation big data analytics platform on their cloud infrastructure. They need a storage service that's going to provide the scale and the performance that their big data apps require, such as high throughput to compute nodes, coupled with read after write consistency and some low latency file operations. In addition, their data needs to be stored redundantly across multiple availability zones, and it's got to allow concurrent connections for multiple EC2 instances hosted on multiple AZs. That's a lot of words that all point to this like one service, right? So which of the storage services would you use for this requirement? Because honestly, it just said file operations, which by the way, automatically takes all the object storage off the system. So it can't be S3. It can't be Glacier because those are object storage systems and you're not going to do file operations on them. Remember, that's a remote storage system. You do not mount S3 and Glacier inside the operating system. So it can't be the object storage options. Now, it could be EBS and it could be EFS, but someone tell me why EBS isn't going to work. What is the requirement up in the question that tells you that EBS cannot do this?
Connections from multiple instances.
Well, in Rakesh, oddly enough, EBS can support a single data volume, a single EBS volume can support connections from up to 16 different boxes. But you're right, Rakesh, in the sense that you would never do that.
Yeah.
It's a bad idea, but you could. Technically, you could. That's not actually the requirement that makes EFS the answer. Although you are technically correct, we would never do that in real life. More than one EC2. So Connor, same thing. You can actually hook in up to 16 boxes to a single EBS volume. By the way, I discovered that on accident a couple months ago because there was this multi-attached thing that came up on under EBS. And I was like, what does that mean? And I was like, oh, you can attach multiple EC2 instances. Here's the problem. EBS volumes only live in one availability zone, just like a virtual machine only lives in one availability zone. So the requirement for the storage to support multiple AZs, that changes it to EFS because EFS will span an entire region. I also want to be clear though, Rakesh, is that file operations can happen with EFS and EBS because they both mount as a hard drive underneath the operating system. So they both mount the file system. So it really is that EFS supports multi-AZ that is the distinction between that and EBS, because EBS could actually do all of the other things, but EBS volumes exist in one availability zone and only one availability zone. So if you had systems in other availability zones that wanted to attach that EBS volume, they can't. So EFS is the only answer. Now imagine I said all that. It's like, well, Michael, you're wrong. Actually, EBS is the answer. No, it's not. So, so that makes the EFS the right answer. So let me make sure we're clear. You cannot do file operations on S3 and Glacier. That's object storage. That's a remote storage system. It does not mount underneath the operating system. But you can access files concurrently, and you can access them across an entire region. So it does actually fit that requirement, right? But no file operations takes them off the table. Okay. Okay, I'll let you read this one. This one's a little bit of a gimme, right? Let me ask you this though. If that said 1,000 Windows boxes and instead of NFS version 4, it said SMB version 3, what would be the answer instead of EFS? What was the other shared file system service called? Yeah, good. And to be clear, Mike, your answer is the most technically accurate, because remember, FSX has 4 flavors of file system underneath it. FSX for Windows is the only one out of those 4 flavors of FSX that's built for Windows. So make sure that we're being like specific with our language. Mike, that, you know, I don't remember anything that Forrester talked about, but he said not memcached, right? That's good. All right, last one for this one. Well, hold on. Well, I don't know about not GCP. GCP is pretty good. I'll let you read this question. Make sure before you answer, you read that last question in detail. Okay. Now, another key thing about how Amazon thinks about these things. I don't know why they're so happy about this, but first of all, if I want a scalable, highly available shared file system, there's only 2 options, right? It's either FSX or EFS, right? FSX isn't here. So it's going to be this. Remember, S3 is not a shared file system. Elasticache is an in-memory database. It's not a shared file system. EBS volumes are not shared file systems. They're not, right? So that's not going to work. And the thing that really throws this over the edge is that Amazon's really excited about the fact that EFS is POSIX compliant. Now, no business I've ever talked to has ever cared about that. But Amazon's really happy that it's POSIX compliant. So if you see the word POSIX compliant in the requirements, they're probably talking about EFS. Now, let me be clear, you can actually get an EBS volume with a file system that's POSIX compliant. But when they say that, they throw that word in there. It's like when they throw in a question where, which licensing type do I use if I have an app that can withstand interruption? The answer is usually going to be Spot. If they put the words POSIX compliant in the question, they're probably looking for EFS as the answer. Notice I said probably, not always, but like 99% of the time, it's going to be POSIX compliant. It's going to be EFS. Just something to side note. And by the way, if you ever need a POSIX compliant file system that's shared across multiple servers for Linux, you could use EFS. I put that up there and I'm like completely wrong. So, that's just something they just harp on. I'm not sure exactly why they're so happy about that. It's not really hard to achieve POSIX compliance. So, moving on. All right, let's answer a few questions on RDS, since that's the only other section that we have, because I don't think we have DynamoDB. Oh wait, there is a DynamoDB. So you know what? We will actually do Dynamo. We'll do both. Okay. So analysis for the first one. So application that records weather data every minute is deployed in a fleet of Spot EC2 instances, and it uses a MySQL RDS backend. Currently, there's only one RDS instance running in one availability zone. You want to improve HA by adding synchronous data replication to another RDS instance. Which of the following is going to perform synchronous data replication in RDS? Okay, let's talk about the definition of synchronous versus asynchronous. Synchronous means you have two systems that are staying in total lockstep with each other. They are totally synced with every change. What do you do to a database when you want to change the database? What do you do to it? What action do you perform?
All right.
All right. Thank you. Thank you for keeping it simple. There's probably like 1,000 answers to that. So you were right. So let's say you write to the primary database. So the client, the application has opened a connection to talk to the primary database because it wants to insert some data into a table inside the system. When the primary database receives that data, before it tells the client that I received the write and we're done, it writes over to the secondary database. The secondary database says, I've got it, I've written it to disk. And then it writes back to the primary database, says, I got it. And then the primary database tells the client that it's done. That's called a two-phase commit. Phase one, I write here. Phase two, I write here and let them know. And then we're done. And if you do not write the data twice, if you do not do a two-phase commit, it is not synchronous data replication. Because if there's a power loss, right, my data is lost because it's not replicated over here. Synchronous. Asynchronous replication happens when a client comes in and says, I want to write to the primary database. The database says, you know what? I got it. I wrote it to my disk. You're good. And then later on, it will replicate the data to the secondary. Which, by the way, means that if the primary goes down, the secondary never gets the data because there's some gaps there. It's not in lockstep. It's asynchronous, right? So to say this, A was listed as the answer, and that's not right. Read replicas do asynchronous replication, meaning the primary gets the write, sits on it, and as soon as it possibly can, it sends the write out to all of the read replicas. But it is not in lockstep. There can be a gap or lag between the read replica and the primary writer database because they're asynchronous. They are not in lockstep. So this comes up as a question frequently on the exam, is that do you understand the distinction with the fact that multi-AZ uses synchronous replication and read replicas use asynchronous replication? And to be clear, I appreciate that they do that because if that read replica is in Tokyo and your primary database is in Ohio, there could be a tremendous amount of latency, especially if that database is being written to pretty frequently. And if it couldn't actually write the commits back in time, it would lock up all the clients, queue all the clients up. The clients would just stack up, all trying to do a write because they're waiting for the Tokyo database to respond to the primary database. This is why read replicas are asynchronous, because you do not want the primary writer database to get all choked up because it's having to wait for 3 replicas to respond. That's why they're asynchronous. So just put it in your brains that when you click multi-AZ or multi-AZ cluster, because that was the new option we saw yesterday, you are creating a synchronous in lockstep cluster of writer databases, and they are using synchronous replication. If you create 15 read replicas talking to one writer system, they are using asynchronous replication, and you can actually see it if you go into CloudWatch. You can look at replica lag and see what the difference is between the read replica and the primary database. Like, how many changes different is it? Because if the primary fails and it was in the middle of writing 2 changes out to the read replicas, they won't have it. Okay. Is that clear? Is that not clear to anybody? That's a better question.
That makes sense.
Okay. This is dumb. So that doesn't even make any technical sense. You can't even do that. And then what is the DynamoDB read cache or read replica called? Does anyone remember? It was literally like one slide, so I'd be shocked if you had that embedded in your memory.
DAX.
DAX. Okay, good. You did have it. It's not memcached. So DAX, right? So DAX, by the way, is one of the most expensive things you can add to your DynamoDB installation to get to that microsecond response time. Has nothing to do with RDS, so it's not at play here. Okay. Let's you read this one. I see that some of you, when you play poker, apparently you like to hedge your bets. So, and I'm not just saying Alex. Make sure when you put an answer, you commit to that answer, even if it's wrong. Go in all in. Be totally wrong, right? Or totally right in this case, right? All right. So most of you put A and C. Let's check it out. So 1, if you got this one wrong, we need to talk, because I think I just ranted about this for like 2 minutes. Right now, this one, read and write operation. Well, if it's a read replica, it shouldn't handle writes. So hopefully you figure that out. And if you got this one wrong, we should definitely talk, because did I just rant about this? And then this one actually technically doesn't even make any sense, because Global Accelerator, by the way, is a global load balancer. Has nothing to do with databases. So that doesn't even make any sense. So even from elimination, you could kind of scale those out. So obviously, hopefully this one was like first one on your radar. And then this is true. And notice it says read heavy database workloads. By the way, the read replica that you create does not have to be the same size as the primary database. The primary writer database, and even the primary writer database in a cluster, those 2 boxes need to be the same size, right? Because they're going to fail over to each other. The read replica can be bigger than the primary database. It doesn't have to be the same size. So if you get a bunch of reporting applications that you don't want to touch the primary production database, they can go talk to a read replica that you spawned off and then go to town on that database all day long, right? And you can even make that database bigger. So read replicas are perfect for performance. Note that adding a multi-AZ box, so a synchronous pair, is not going to improve performance. So be careful, because they're going to try and trick you. You get HA, but you don't get into performance improvement. If you add a read replica, you get performance improvement if you offload your reads to the replica. Good. Huh. All right, last one for this section, and we'll switch over to DynamoDB. I'll let you read this one. Keep going. I'm just off camera for just 2 seconds. All right, Connor, which is it? Is it A or C? All right, Rakesh, I want you to think about how you integrate Kubernetes in with AWS. Okay. So I want you to all just kind of put this in your minds for a second. Whenever you initiate another system inside of AWS, what do I mean by a system? Operating system, database system, orchestration, container orchestration system like Kubernetes. Whenever you initiate another application system inside of AWS, that system is not hooked into IAM. Are you following me? You can't log in to your EC2 instances via IAM unless you somehow connect the operating system into IAM. You can't take a database engine, and the database engine has its own username and passwords. It is separate from IAM, which is used for AWS. Kubernetes uses certificates to identify users. It has its own user management system, even though it's really simple. It does not federate unless you federate it with IAM. Now, this is just something you need to know about RDS and operating systems in Kubernetes, because Amazon more and more is giving you the ability to check a checkbox to get those systems to federate with IAM. So this is just some very specific piece of information you need to know, that for RDS, if you want to make this work, you've got to federate the two systems together. Now, I see a lot of, at least like A's, D's. I'm going to go with A just to give an example, but the answer is actually B. There's a checkbox to say, look, I want you to federate the database system with IAM. So remember, anytime you start a system of any type, if you want to log in using IAM, you got to connect those two together. Otherwise, you won't be able, you'll have separate logins, separate database logins, separate operating system logins, separate Kubernetes logins. I'm trying to think of other ones that I've run into, right? But those are the major ones that you run into. Okay. So this is just something very specific you got to know about RDS, is that in order to enable federation between the database system and IAM, you got to hit that checkbox of enabling the IAM DB authentication. If you want to get your operating system to talk to IAM, I think you have to like turn on a PAM module, or you can just use Systems Manager, which will also do it for you, right? Kubernetes, the same thing. Kubernetes will federate in with IAM. You can actually set up a trust relationship as a trusted, my brain just stopped working, identity broker, and it will basically allow you to hook, you can log into Kubernetes and manage it using your IAM user. Okay, so just remember that IAM DB authentication is the checkbox you have to hit in order to get RDS to federate in. Okay. All right, last one. Let's do DynamoDB. Okay, analysis on the first question. So we got a mobile game that uses CloudFront Lambda and DynamoDB for its backend services. Player data is on a DynamoDB table, and the static assets are distributed by CloudFront, probably with S3 underneath it. However, there are a lot of complaints that saving and retrieving player information is taking a lot of time. What can we do to switch the response time from milliseconds to microseconds when it comes to DynamoDB? I think we just talked about this. Anytime you see that millisecond to microsecond phrase in relation to like databases, especially Dynamo, the answer is going to be DAX every time. It is the only one that does that for DynamoDB. That's it. There's, as far as I know, there's no other way to get it down to microsecond response times other than using DAX. Okay. For those of you who want to know, by the way, Device Farm is a QA farm for multiple mobile, tablet, whatever devices. So it simulates iOS, Android, and other devices, like, so you can do testing if you're like on a QA team. All right, let you read this one. Okay, I got a couple of C's here. Interesting. Let's see. Now, here's the problem. What is the underlying database technology for Aurora? What's the two flavors that feed Aurora?
It's MySQL and Postgres.
Exactly. What types of database engines are those? Like, what, say again?
Relational.
They're relational. So they're RDBMSs, relational database management systems, right? can you change the schema of RDBMSs easily? Like with very little like consequences? Are the schemas super flexible?
No.
No. Matter of fact, schema changes are tended to be avoided, right? Inside RDBMSs. You can make them additive. You can add stuff to your columns to your tables all day long. But if you decide to change the nature of how the tables and whatever the schema, the structure of the database, that is typically frowned upon. You don't do that lightly. You don't mutate your schemas. You can add to your schemas, but you don't mutate them. That is typically frowned upon in RDBMSs. I say typically because none of that's hard and fast, right? So that requirement makes it weird to choose either RDS or Aurora or Redshift because these are all RDBMS based systems. They don't handle schema changes as easily as a NoSQL system, which is what DynamoDB would be. The other thing is that, and this is a little fudgy, is that it said scale globally. Now, don't get me wrong, Aurora actually has some amazing scale pieces to it. Some of them are actually quasi-global, meaning you can go to other regions, but none of that happens as easily as it does with DynamoDB. DynamoDB will scale easily to a like 27 table global setup, no problem. So just remember that key distinction is that in the industry, schema changes are typically not handled as easily with an RDBMS as they are with a NoSQL system. And so notice they left this vague requirement, said, what's the most suitable? So they're going to evaluate, you know, what is the most suitable from an industry standard perspective? That's what they're going to throw out there. Any questions about that? Okay. Last one. Let you read this one.
Oh, I can't hear you.
Yeah, we can.
Microphone's up.
Probably helpful if I lowered my boom mic. So like the IAMDB authentication that was in RDS, this is something you just have to know about DynamoDB, is that it has an agent, like a change, like an event agent that watches tables. And if you turn it on, it can then trigger and notify other things like Lambda that something has happened. And it will actually send either just the keys, the old data, the new data, or both over to the Lambda function or whatever, CloudWatch events, whatever you want to trigger. So streams is used so that when changes are made to a table, it will actually watch the table, see the change, and then call a Lambda function to do the thing in question, in this case, a test, right? So this is, you just have to raw know is that DynamoDB has this streams feature, which watches as data streams in and triggers a response based on rules you set up. So that one's just more of just a straight up knowledge piece. Streams, by the way, is what the global database tables use. so that when like a table in Ohio is updated, streams then triggers an event that talks to a Lambda function that then pushes that change out to every other table in the global set. So global DynamoDB global tables actually uses streams underneath all of the tables to make sure that all the changes are constantly being replicated across the entire environment. But streams is an event tracker, an event agent that tracks events that happen against a DynamoDB table. And you have to turn it on a per table basis. So you have to like set the stream up on every table that you want to track changes for. So it triggers, right? That's what they call them, as triggers. Okay. Good enough? Give you a little sample of what's going on in those spaces as far as AWS goes. Any questions about any of that? All right. There's a certain point in time, by the way, where I just skip these questions. Does anyone have anything they want to share about the factors that you impact your decisions for making workloads scalable? May ever run any trouble or have any funny stories they want to share about that? You don't have to. I just thought I would ask. I feel like most of the time, scalability decisions don't necessarily get prioritized for the deployment of a new application until there's an outage. Does anybody else ever run into that? Every once in a while, I'll get to like soak up some high availability, especially if the business is clear that like, hey, this is mission critical. I wonder in a financial institution if that's much different, where they're like, oh no, this thing needs to stay up. So you cannot negotiate around scalability and HA and fault tolerance. Do you guys automatically have that in mind when you like deploy designs? Because a lot of environments just test the water with like almost like a simple application that isn't HA or fault tolerant, and then when it gets popular, they'll start adding in more components. I don't know if it operates that way where you guys work. It sounds like with financial trading that would be an acceptable option.
From the networking side, we definitely have that. Like if we have an outage at a site, or if we're doing maintenance, we need to like move the VPN and stuff. So we need to make sure, you know, different sites can work off that load.
Well, I imagine it's not negotiable with networking in particular, right? Because the network goes down, pretty much nothing works, right? So you always have to have redundancy, I would suspect, with a network, no?
Yeah, a lot of our networks are kind of at the edge location versus like a data center for faster trading speed. So there can be like a site with, you know, over 1,000 people might need to use a device out of a site with less than 100 people. So. And
so that's a scale based on usage patterns. Like what you expected usage, right?
Right. Yeah.
Okay. So we're going to move into monitoring and scaling. There is a lab associated with this one. So we're going to be configuring high availability inside our VPCs. So here's the kind of feedback here is that, you know, popular phrase that someone's just thrown around, you can't really monitor or manage things that you're not measuring, right? Like you can't really manage things that you're not really monitoring and measuring. Like if we don't have data, we don't have state changes, we don't know what's going on with the system, obviously, regardless of whether it's coming from the operations team or not, if you don't have data on the system, you don't know what the system's doing. You're managing your infrastructure by guts, what I call guts and glands, right? That's how you're managing if you don't have data. And oddly enough, there's been many successful businesses that have run off of guts and glands, but ideally setting alarms and thresholds and stuff like that gets a little bit more methodical instead of relying on luck and responsiveness to fix things. Also, when you start to talk about that, it's also the ability to respond to increased usage, like increased like workload patterns. This is where things like load balancers and auto scaling become incredibly important. And so how do you optimize, the capacity based on demand? Because you want to stay kind of like right pretty close to as demand goes up, capacity goes up, demand goes down, capacity goes down. You don't want to get overloaded. So how do we respond to that from an auto scaling standpoint? And so like, what can we use to not only check all states and logs in the AWS account, but how do we check the performance of these systems that we've kicked off? We kicked off operating systems, kicked off Kubernetes systems, we've kicked off database systems, we've kicked off all these other services. How do we track performance? Is there a way for us to set up alerting? And then how do we do that capacity chase that I'm talking about, where demand goes up, capacity goes up, and vice versa? How do we do that? So here we're back to our design, and notice that some things have been colored in, like EFS should still be colored in. RDS should be colored in, Memcache colored in. But for the purposes of this module, we're really only talking about the auto scaling group, the ELB, and then we're going to talk about some ancillary services that are useful from an operations standpoint to set up alerting, audit your account, and to trigger responses, particularly from third parties. So let's talk about monitoring first, right? If I have a problem, where do I look? Well, first of all, just know that pretty much everything starts with CloudWatch. That's the metrics repository for the entire system. There are other services though to look at. Now, we monitor for a variety of reasons, but I think I outlined it pretty clearly before. If you don't have data, you don't know what's going on with your system. And if you're not reading that data, massaging it, reporting on it, adding thresholds to it, you're not looking at it, you're going to be figuring it out when you have a problem. And when you have a problem is the worst time to be figuring out what your process is going to be. So CloudWatch is where all the metrics get collected for real time. And CloudWatch has about 11 subservices underneath it. So if we, oh, that's right, I meant to look at that. I'm gonna go take a look at that later. If we come out here and go out to CloudWatch, note that on this left-hand side, right, I've got alarms, logs, metrics, X-ray traces, which basically is like open tracing, like application tracing, CloudWatch events, application monitoring, and insights. Even underneath these, for example, let's look at insights. There's 4 subservices under insights. So if we break this down, I think at last count there were 11. Oh, they've added more. They've added more services since I actually looked at this even just a week ago. That's been there for a minute. They didn't call it evidently though. RUM though, optimizing end user experience. Wow, look at that. So they're really going for end-to-end kind of tracking, but this is where all of your monitoring, logging, all of your performance insights are going to come from. So whether it's you're tracing and you're creating like a service map of an end-to-end application, whether you are looking at core like metrics, such as, let's say that I'm running an EC2 instance and I want to know the metrics for this, Cloud9 instance that I'm running, like the EBS IO balance percentage or whatnot. You just choose the metrics that you want to see up on the graph, and it just starts showing you like whenever that is run. Now, notice this instance only ran for about half an hour because that's the way Cloud9 functions. But, if I want to look at this over a period of time. And then logs. So if I have any logs written out here, this will all be in the log group. Notice this, you can see the history of stuff that I've been tinkering with. Everything from RDS to SageMaker to Lambda stacks to code build. And then alarms is just like when you want to set alarm thresholds. These alarms, by the way, can trigger responses. So I could come in here and set alarms for all kinds of state changes. And then events, which was so popular that they actually started another product called EventBridge, excuse me, based on this, allows you to create event buses that basically you can have third parties dump into, or you can talk to third parties. So either way. So you can integrate actually SaaS partners like Datadog or Salesforce or other events into your system. So notice there's a number of services, far more than the 11 that was here even 2 weeks ago, are now like part of the CloudWatch pantheon. Joking as a pantheon. So CloudWatch is a very robust set of services. In addition, you know, CloudWatch, like I said, the alarms, you can like write logs out to CloudWatch if you want to. You know, it can do things like trigger notifications. It can trigger auto scaling. It can trigger you know, Lambda function if you want to. And all these statistics can be pulled out through the API, or you can look at them through the management console. Now, that being said, about all the metrics that you could look at, there's a number of places where you can host logs, and there's all different types of logs. There's security logs, which is what's, you know, CloudTrail is really a security tool. There's logs from other services. There's logs from your application. There's network logs, which is what VPC flow logs are. And then you might submit custom logs from either your application or, you know, from your like your specialized database tool, right? Doesn't matter what it is. You can submit all the logs you want into CloudWatch logs, and it will take them. And you can look at them through the dashboard. You can actually use CloudWatch logs insight to actually process them. So CloudWatch logs will take external events, put them into a log group, do some aggregation, filter it down, and you can actually, I jokingly refer to this as metricize your logs, like looking for like, let's say 500s or 400s or whatever, probably 500s. And you can trigger responses based on those 500s, right? Or whatever regex value you want to put in those logs. Now, CloudTrail, as opposed to CloudWatch logs, which remember, CloudWatch is the metrics repository, logs is just a subservice, just like CloudWatch alarms is alarms, CloudWatch metrics is just metrics, CloudWatch logs is just a subservice of CloudWatch. There's also a security tool called CloudTrail. This is a security tool. This is not a performance tool. I want to be super clear about this, because its main job is to facilitate security analysis and security auditing against your account. Don't get me wrong, it can do operational tracking because that's part of security. But when you turn this on, it's going to record every API call made against your infrastructure. Here's a little quiz. If I make a change inside of my Windows box on my EC2 infrastructure, is it going to show up in CloudTrail? Yes or no?
Yes.
Well, what did I say earlier about external systems? That's an external system, right? What do I need to do to get the logs from an external system into AWS? Well, I have to emit those logs, don't I? I have to write those logs into CloudWatch. Remember, otherwise, the Linux box, if it's a Linux box, for example, instead of Windows, is going to have its own log repository inside the operating system. If I want those logs to come over to CloudWatch, I got to go put them into CloudWatch. But they're not going to show up in CloudTrail, because CloudTrail is only for API calls made against my account. If I'm inside of a Windows box tinkering around, not only is it not going to show up in CloudTrail, it's not going to be in CloudWatch. Because remember, AWS does not by default gather all the information that's inside your operating system. They will only get information from your operating system if you give them permission to do so, which means you'd have to go back, start a CloudWatch logs agent on your operating system and ask it to export the logs. But CloudTrail has nothing to do with any metrics or performance. It is purely a security tool. It is used to audit any API calls made against your account. Now, I keep saying API calls. If I use the console, is that an API call into my account?
Yeah. Yep.
If I use the CLI, is that an API call into my account?
Yep.
If I use the SDK or the CDK, is it an API call into my account? You're like, yeah, we just said yes twice,
Oh,
Michael.
yeah.
Do we really need to say it a third time? Yeah. So bottom line is that, again, if you are manipulating AWS infrastructure, it shows up in CloudTrail. If you are looking for metrics about the performance of your services, that is only CloudWatch. So again, CloudWatch is performance, CloudTrail is security. Remember I said that. Here's some of the logged activity, by the way. If one of the hidden Daves decides to go in and impersonate Dave, I'm not naming names, I'm just saying I know some of you already probably would do this, goes in and decides to shut down Dave's, development server, you might want to track and see who that was, right? That's what CloudTrail is for. CloudTrail is a security tool. So if someone goes in and shuts down Dave's server, let's say it was somebody named Alex, and they shut down the server, you could go see that, Alex was logged in at the time in CloudTrail and shut down the server. So again, CloudTrail is for security permissions. It's for security checks against API calls against your account. Here's an example. Who made the request? Well, this was an IAM user who apparently is called X Principal ID. We don't know who that is, but they also could be called Alice, right? And so here's Alice, and then Alice has an account ID. Example key ID doesn't matter. So this is who made the request, right? What did they try to do? Well, the focus from a resource perspective was they talked to this instance. Okay. When did it occur? Well, sometime in 2018. And what did they do? Well, they tried to stop the instance in US West 2. Where did they come from? Here was the source IP address. And what did they use? They used the EC2 API tools. Looks like the command line, 1.6. And then what did the system say back to it? It said, hey, you know what? This is the previous state was running. We're going to go ahead and switch to code 64 and we're going to stop. So that it was successful in executing. That's all CloudTrail. This is security function. Now, if CloudWatch is for metrics, CloudTrail is for security API calls, like auditing your API calls, and it does log, by the way. What do we do about the network? Well, first of all, you probably saw earlier that you can actually mirror all traffic into an RSPAN port for your account. So if you want to dump that over to a deep packet inspector of some type, you can do that. But a lot of people will turn on what's called VPC flow logs. This is the best way to see how traffic is getting into your account, either from direct connect from VPN or from the internet. So you can configure this, by the way, per VPC, per subnet, or you could literally say, I just want to see all the traffic going to this network interface. They are turned off by default. And so you can publish them to either S3 as flat files, or you can put them into CloudWatch logs if you want to, right? So you can diagnose whether a firewall is rejecting traffic. You can monitor traffic that's reaching your instance. You can determine how traffic's flowing inside your systems, right? So flow logs can be very helpful for tracking network flows. Here's kind of a non-JSON list of what's in there. Source address, destination, source port, protocol. Was it accepted? What was the size of the data? You can push those VPC flow logs to CloudWatch if you want to. Not much to that, actually. You can also publish them to S3. It will, by the way, aggregate the logs for a 5-minute period and then write them out, aggregate them, write them out, aggregate them, write them out. So just know that that's not a real-time process if you write them out to a flat file. So every 5 minutes, it'll be updated. Okay. Any questions about CloudWatch, CloudTrail, or how VPC flow logs, are used, right? Basically.
I guess for CloudWatch is the one that does the alerting primarily, right?
Right. It has alarms in it.
Okay, so like if you wanted to alert on something that's security related, that would be something you configure in CloudTrail and then tie into CloudWatch to get the alert.
What you could do is you could dump your CloudTrail logs into CloudWatch logs, and then have it so that if it saw a certain kind of pattern or string or value, that CloudWatch alarms would kick an alarm off.
Got it. Okay.
Yeah, but it'd have to get into Cloud Watch for that to function.
Right. Okay. Cool.
Yeah. Speaking of alarms, so you can like trigger responses to certain events, whether they be log based or metric based, right? So you just identify the metric or the log value that you want to respond to, create the alarm based on the particular metrics in question, and then define the responses that you want. That response, by the way, could be call a Lambda function, send an email. CloudWatch actually has a lot of alerting and like response capabilities. So you can create your own kind of self-healing architecture if you want to. Alarms, by the way, can either be in two states, meaning they're triggered, they're not triggered, or third, I just got started. Or there's no data for this metric that you're looking for. So like, for example, if there's an empty SQSQ, it doesn't have any information because there's not like the queue's not even really running. It's not even like up and working. In other words, if you said, hey, what's the depth of an empty Amazon SQSQ? Well, the depth is 0. So there's actually nothing to report because there's nothing in there. Now, why wouldn't it just report 0? I don't know. That seems like a pretty decent value to report, but there's no depth to it in that particular instance. So if you see insufficient data, it's either because you're not getting metrics because you just started the metric tracking, or the flow of metrics into that particular like metric category is not happening. It got disrupted or stopped in some form or fashion. Now, there's a couple of different components to think about here. Like, for example, a namespace is a container for a CloudWatch metric, right? So metrics and namespaces are pretty isolated from each other. Namespaces usually follow service conventions. So like Lambda is a namespace, EC2 is a namespace, RDS is a namespace. And then what will happen is that all of the EC2 metrics from every EC2 instance will go into the EC2 namespace. Every RDS database, its metrics by instance will go into the RDS namespace. Now, the metric itself just represents a time-ordered set of data points that represent certain values like CPU utilization or memory or whatnot. And the dimension is like the name value pair that like identifies the metric, right? Like you can think of dimensions as categories or characteristics of the data, like CPU utilization, right, over time. And the period is just the time in question. So by default, CloudWatch will track data every 5 minutes. If you turn on detailed monitoring, it'll do it every minute. In other words, it will surface a value every 5 minutes. If you turn on detailed monitoring, it's going to surface a value every minute. You can make it less frequent than that. Like if you want to do seconds, you can do that as well. But by default, it does minute and 5 minute. Now, once the alarm threshold is set, like you've set an alarm threshold, and that alarm gets crossed over whatever time period you specify, that alarm is triggered. And so it's going to execute the response plan that you associated with that alarm, which could be like call a Lambda function, call the boss, right? Could be a bunch of different responses. Once it gets to Lambda, by the way, your only limitation is code. So you can do anything you want once you get to Lambda. So for example, in this one, it says, look, I only want you to trigger if you go over the threshold for more than one time period. So the first one doesn't trigger, but the second one does, even though it's not as high as the first one. because the alarm says, I only want you to trigger if it goes over 2 time checks, 2 time intervals. So that's CloudWatch alarms. Allows you to set alarms based on metrics. You can also set alarms based on log strings as well. Now, CloudWatch events allows you to basically track all the system events that are happening in your AWS account, like changes in resources. For example, if someone starts an instance, you can automatically have it send an email and say, hey, by the way, someone just started an instance. Someone just deleted an instance. Someone just modified the firewall. Someone just opened up S3 to the world, right? So with simple rules, you can match these events and then basically like respond however you want to. You want notifications? Great. You want to lock it down? Great. Because CloudWatch events is going to become instantly aware of any operational changes to your AWS account. So you could activate functions, you can make changes, you could capture state information, you could send notifications, right? And so EventBridge is built on top of and extends CloudWatch events. Uses the same service API, same endpoints, but CloudWatch events is not like being deprecated, but CloudWatch events is really for kind of third-party initiated workflows. You know, as an example, you could have Salesforce trigger some kind of response that then causes an event to happen inside of AWS. You could have an external application on your data center push an API call into the custom event bus, and that could trigger a response in your infrastructure. Like, hey, I want you to open up this port because I'm about to send data to you, and I want you to open up this port. I'm going to send the data to you, and then when I'm done, I'm going to send you another trigger, and you're going to close the port because you don't want to leave the port open. Things like that. Really, your imagination is the only limit for what you can do, either triggering or responding to events inside of AWS. The main job here is EventBridge is trying to like remove the like barriers to like doing point-to-point integrations. So they're trying to let you use your SaaS applications to make changes to AWS and your AWS to make changes to your SaaS applications. So you get a really simple programming model, kind of like if you're used to if this, then that, or Zapier. They're trying to like work in that space from an infrastructure standpoint to a certain degree. So it's fully managed, so it handles everything from event ingestion to scalability to authorization. So it's serverless, no infrastructure, and you only pay for events as they run. That's it. Okay, that was CloudWatch alarms, CloudWatch events, and EventBridge. Just to show how you can like have triggers and then trigger events or respond to events or initiate events using CloudWatch events or EventBridge. Okay. Assuming there's no questions. Oh, let me bring up my chat because I may have missed one. No. Okay. Last two are going to be familiar to you because we've talked a little bit about them already. But what about load balancing? What if we want to be able to distribute from a single point of entry traffic across a whole different set of servers? And you can see there's different target groups here. There's the main target group, which has example.com. There's a target group that has blogs. There's a target group that has mobile. Notice that some of these are conjoined, right? You've actually got one target that actually belongs to both groups. I gotta tell you, that's a little weird, but you know, you could do that. I don't know why you would run two applications on the same system, but I'm not here to judge. Notice that there's a listener that's listening on a particular port, right? And it's got a rule in there. And that rule is where the slash blog and the slash mobile and like I don't care about the slash. That's where those distinctions happen, right? If it says slash Americas, slash EU, slash APAC, slash Africa, slash Antarctica, it didn't matter, right? Those will all be rules inside the listener. So the target groups, by the way, that you see down there, those are where your EC2 instances or your ECS containers or your Lambda functions are registered to the target group. And then the target group is associated with the rule. By the way, if you heard me talking yesterday about algorithms like least outstanding or round robin, where do you change that at inside of a load balancer? Huh? Too distracting yesterday? That happens inside the target group, by the way. So if you want to change how routing happens, you have to change it within the target group. Now, load balancers look like single devices. They are not. They are virtual devices. Like they look like a single device, and they're made of many virtual devices. So these load balancers are going to do either layer 4 or layer 7 load balancing, meaning they're either going to do web traffic or they're going to do TCP/IP traffic. Now, there are currently, soon to be more, 4 types of load balancers. There's the layer 7 load balancer, which is the application load balancer. That's probably the most popular one. It can handle, tens of thousands of connections per second. It just depends on what the payloads are. Then there's the network load balancer, which Amazon will tell you will handle millions of connections per second. That's not true. It'll handle hundreds of thousands of connections per second. And then there's the gateway load balancer, which it really allows you to like deploy and scale third-party appliances. And here's the cool thing about it. This operates at an IP level. So this is low level, right? So this is going to be layer 3. So like if you want to launch deep packet inspection or some kind of like security signature checking, gateway load balancer is going to be your friend, right? So you can deploy, like these advanced appliances. You just have to look at the marketplace to see what you want to grab, right? The classic load balancer, by the way, is being retired. Matter of fact, as of, I want to say August of next year, it'll be gone. I think they put out a retirement notice for it. You don't really use the classic load balancer anymore for anything. This predates VPCs. Isn't that weird? One thing to note is that, for example, this table is a little out of date. Application load balancers can now have static IP addresses, as an example. I think the rest of this is actually still pretty accurate. Main thing to take away from this is that if you need advanced pathing and routing, you need to use an ALB. If you want extreme performance from a very simple TCP/IP based router, you're going to use a network load balancer. You're not going to get fancy features though. If you want to pull in a third party, then you're going to be using a gateway load balancer, right? And then again, classics don't use it.
What is connection draining?
Basically what it means is that it basically allows it to basically finish the session without just cutting it off at the knees. So it'll slowly drain connections off of a box instead of just cutting the box off. If that makes any sense. So what will happen is that when you deregister the box, it'll slowly take all the sessions and as they reset, instead of directing them back to that box and just cutting them off, it'll slowly allow those connections to finish. And then it will push those new connections off to the other boxes that are active. So it allows you to gracefully exit a EC2 box or container out of the system without cutting the user experience off. So it gracefully exits the
Okay, got
Yeah,
it. Yeah,
yeah.
like it won't interrupt the packet flow.
Right. It's like, because it used to, if you deregistered an EC2 box, it would just interrupt the connection right away. You're like, whoa. And then users would be like, what just happened? And usually they just refresh the page and go about their business. But that doesn't always, that's not a great customer experience. So those are the load balancers. We are going to add a load balancer into the lab, so you're going to get to touch one, see how it works. The one thing I wish they had is that I wish they had a gateway load balancer lab. I think I have one. I'm going to dig it up and post it in the chat. But the gateway load balancer is very different from the other two load balancers. So you can actually make it look like the other two load balancers, especially if you use like an F5 or whatnot. But do note that it operates very differently. By the way, this does not stop you from launching an F5 virtual appliance or any other virtual appliance into your infrastructure. So don't think that you actually have to use the load balancer object to actually get your favorite load balancers into the system. You can kick them off from the marketplace if you want to, and they run as kind of like load balancer objects, but they're not official AWS load balancers. So don't be fooled. You can still launch whatever load balancers you love from the marketplace into your account. Okay. Last section, and then we're going to roll into a lab. Let's talk about auto scaling. So you may remember that I said that basically if you throw CloudWatch and load balancers and auto scaling all together, this is the secret sauce that makes virtual machines cheaper on Amazon than they are in your data center. That's a pretty bold statement because you might be pretty good at running virtual machines in your data center. But I just got to tell you, the ability to scale down when you don't need to be scaled up and the ability to scale up on demand means you don't have to buy hardware for your maximum demand. You're not in that game anymore. That's Amazon's game, not your game. So that means you're only paying for the stuff you're using. So this final step around auto scaling is it works like the way you think it would. You get a bunch of web servers that are exactly identical, and you horizontally scale them up based on whatever metric you define. Is that latency? Great. Is it latency, CPU utilization, memory utilization, disk utilization, network utilization? Great. You can do that as well. You want to run it externally? You can do that. You want to run it internally? You can do that. The only time ASGs really don't work super well is with like an RDBMS. You're not gonna auto scale your MySQL database. You might auto scale the read replicas. You could get away with that, but you're not going to auto scale your primary writer database. You could get away with auto scaling your Elasticsearch cluster because that's a cluster that you can add and no real issue. You got to be careful around churn with that, but you could do it. This is how it works. Is you think about what you can scale, you create an AMI for it. You need to then basically define some parameters. How big do you want to go? How small do you want to go? All that stuff. And so what you can do is you can enable what's called EC2 auto scaling. But I just want a little side note here. Auto scaling exists for Aurora, DynamoDB, SageMaker. There's a bunch of services where you can just check the box and it will scale up as you need it and scale down when you don't. So be on the lookout for that when you use services, because a lot of them are inherently auto scaling. But like DynamoDB, you can check the box and just say, I want you to auto scale. Aurora has the same functionality. We're mainly talking about EC2 auto scaling. Now, in the old days, you had to buy enough hardware to stay ahead of your maximum demand. And, demand though would be rarely like predictable or linear, right? And so if you had more hardware than you actually had demand for, you wasted money, right? And if you had more demand than you had hardware for, so instead of less demand than you had hardware for, you now have more demand than you have capacity and hardware for. Those users are having a bad experience. Your reputation's going down the tube. No one wants to use your service after it gets out on Twitter that they had a bad experience. Now, was it you? It could have been the network. People are quick to blame. Regardless, let's say it is you. You want to avoid this kind of situation, right? Instead, what you want to do is you want to scale, you want your capacity to stay just ahead of your demand. Demand goes up, capacity goes up. Demand goes down, capacity goes down. Lockstep, right? So when you use auto scaling, you've got to have basically either a launch configuration or launch templates. Launch templates are preferred, by the way. Launch configurations, I believe, are the kind of like the old ones. And then you want to use create an auto scaling group, and then you want a policy. So the launch template says, hey, this is how I want you to launch these web servers. The auto scaling group says, these are the maximum and minimum number of web servers I'm willing to pay for. And the auto scaling policy says, what do I do when your metrics are crossed? What do I do when your thresholds are crossed? Like if latency goes above 100 milliseconds, do I add one web server or do I add 5? So all 3 of these components are needed to set up auto scaling. So again, a reminder that they want you to use launch templates. Launch configurations are the old ways. Please do not use launch configuration. They're going to get rid of them at some point here soon. They haven't announced the final date, but they're trying to phase them out. Not only that, you're not going to have half the features in the launch configuration that you're going to have in the launch template. So just use launch templates. Templates are king. The group, the auto scaling group, just says, hey, where is this going to run at? What are my minimums and maximums? And by the way, where do you want to start? Is your desired capacity 6? Is it 8? So you get to say where you want the ASG to start, by the way. And then the policy again says, what kind of scaling response do you want me to have? Do you want me to turn it up at 8 a.m. every day and turn it down at 8 p.m. every day? Do you want me to look at your past history and figure out predictively what you did in the past and assume that's going to be the future? That's called predictive auto scaling. Do you want me to do some kind of dynamic prediction where it's like, not prediction, sorry, dynamic response, where it says, look, if I go above 80% CPU utilization, add 2 boxes. If I go to 90% utilization, add another 2 boxes. If I go down to 60, I want you to take 2 boxes off because I want to stay at 80. You can do stuff like that. There's really no limit to the complexity or the way in which you can respond. Really, the main limit is just your imagination. That's it. So here's the launch template again, right? Just things like, what AMI going to use? Is there a network card? Do I have to do any configuration? All the stuff, the questions you would have to answer if you launched it manually. That's what the launch template is for. And then the auto scaling group definition includes things like what's the minimum and the maximum number of servers, right? How do you want me to terminate them? Do you want me to terminate the oldest one? The one that has the least number of connections, the one that's one version back? And so once you turn on the auto scaling policy in conjunction with the auto scaling group definition and in conjunction with the launch template, you define things like, what are the health checks? Do you want me to set CloudWatch alarms? Is there a schedule? Do you want me to, am I manually turning the dial up and down, right? Great story. Guy, it's like 2015, and I'm working for an advertising agency, which I swore I would never do again. Whole other story there. I am the director of operations. I don't even remember what my title was. Anyway, I'm in charge of infrastructure. I'm in the pit, and all my guys are responding because our board just turned like bright red and everything started falling over. We are at 400% capacity. And I'm sitting there, and my general rule of thumb is that if my guys haven't been trained prior to the emergency, I'm not going to train them during the emergency because it's not going to be helpful, right? If they don't have what they need, they're the experts. They're the ones in the trenches. If I haven't given them what they need at that point in time, me getting involved is not going to help. Me adding to their constraints and worries isn't going to help. So my job was mainly just to stand back and act like what are these? Papa Bear. Do you need a credit card? Here you go. Do you need lunch? Here you go. My job was just to support them as they were doing their jobs, right? So I'm sitting there off on the side. Everything has gone 400% up in the air. I'm like, this is either great or something's horribly wrong. We're getting DDoSed, right? But the traffic looked legitimate. Real users in real time. We could see it. But it was all coming from Asia. We're like, I didn't even know that we had that strong of a customer base in Asia. I'm like trying to figure out where the C levels are at. Is someone over there doing a sale? Are we at a conference? Is something happening? Has there been a tweet? All of a sudden, one of the sales guys pops up, the head of like the sales division. He pops up. He's like standing next to me, and he's all like jacked up. He's like, "Woo!" He's like, "Look at this. You guys are busy." He's like, "How's it going?" I'm like, "Good, Jay. How you doing? What's up? You're usually not in the IT pit. What's happening?" Turns out, as I talked to JJ, it's like, "Well, you know how we get paid per click?" I was like, "Yeah." He's like, "Well, I got this Malaysian click farm that has like 1,000 people in it. I got them to do a test run against our site to see if they could like increase our click traffic." Now, first of all, probably slightly unethical. I don't think it's illegal, but a little unethical. Definitely violates some terms of service. And so he's like, I got this Malaysian click farm, and they're clicking away at our site right now. And I was like, "Really?" He's like, "Yeah." And he's like looking around. He goes, "Well, it looks like it's a success." He goes, "I probably should have told you guys before I had them initiate the clicks, huh?" I was like, "Yeah." Could you tell them to stop? Because it's not legitimate traffic, right? So it's obviously not what we want. And so he goes and he tells them to stop, and they stop the traffic, and everything goes back to normal, which is, by the way, why it looked like normal user traffic, because they had like 50 different scripts they were following, but they were actually people on the other side clicking through our website, clicking on videos and stuff like that. And anyway, the moral of that story is that one of my guys had accidentally set the auto scaling group to 10,000 servers instead of 1,000 servers. And so we didn't even know we could go that high, but that same account had the service quota limits lifted on it because we had done some experiments in it, and we forgot to restore the service quotas back to normal. So we scaled up to like 2,000 or 3,000 boxes. And it really kind of freaked us out for a minute, because we probably, honestly, we only probably spent about $1,500, $2,000 for that little exercise. But I was like, I didn't even know we could get above 1,000 boxes. I thought we had set the service quota limits down to that. And so it was an interesting kind of exercise in watching auto scaling just respond every couple minutes. It was just adding 100% capacity. It just kept going. It just kept adding boxes. So over the course of like 90 minutes, it grew to about, I want to say 1,800, a little, maybe somewhere close to 2,000 boxes. And it was really kind of a really sobering exercise. And it taught us two things. One, make sure your service quotas are restored back to what they were if you decide to do an experiment. And two, obviously make sure that the business can handle whatever financial ramifications you're going to do with auto scaling. So moral of the story is, whatever max you set the auto scaling group to, make sure the business is okay paying for that. So just as a word of note. Needless to say, there was a discussion with the CEO about using click farms in an advertising business. Okay, that being said, remember that you can schedule your responses to load. Like in our case, we only scaled at 8 a.m. and 8 p.m. because that's when our load was Monday through Friday. At other times, we didn't really have to respond to load because it was actually pretty static. We also had dynamic in place in case there was a surge of traffic, which meant that if a CPU utilization went above a certain threshold or latency went through a certain threshold, we added capacity. Predictive wasn't available at that time in 2015 when we used it. Predictive didn't come on the scene until 2018, 2019. Predictive is pretty cool, but as a word of caution, predictive will only work if you have historical performance data for your systems, and preferably 6 months to a year. If you don't have historical data for the performance of your auto scaling group and system, you can't use predictive. So only use that when you have history. Okay. All right. This, by the way, automatically optimizes costs. You can create fleets of auto scaling groups that are a mix of spot, on-demand, and reserved instances. This is a great way to optimize costs, by the way. If you're running a bunch of web servers, there is no reason for you not to put spot instances in there. Because even if the spot instances only amount to 10% of your total instances, they're going to cost you 1/6 to 1/3 less than your on-demand or even your reserved instances. So you're going to see good cost savings, especially if you're using on-demand instances in your mix. So just know that you want to run auto-scaling groups with fleets of EC2 boxes that are mixed using spot and on-demand. Now, if you have reservations and it's pure reservations, run the numbers just to make sure you check it. Couple of things with auto-scaling. You can combine the multiple types. Like I just mentioned that I combined scheduled with dynamic. You can combine dynamic with predictive. You can combine scheduled with predictive. You can combine them however you want to. Be aware that if you have state on your boxes, auto-scaling groups are not going to be your friend. So don't use these with databases unless they're NoSQL databases, and they can suffer a little bit of churn. Scale out early, scale in conservatively. You don't want to scale in and then realize that you needed those boxes because all of a sudden traffic spiked back up. So be aggressive with your spin up, be a little bit more conservative with your spin down, right? So just some best practices there. Any questions about auto scaling in any way, shape, or form? Okay. Do a little knowledge check. Which of these is a valid target for an application load balancer? A, B, C, or D? Yeah, A. By the way, what would be other valid targets for an application load balancer? What do you think? Give me some guesses. What do you think a load balancer could also front? An ALB specifically.
Databases.
Gotta be careful with databases. You can, but only if they listen on 443 or 80. In general, be careful with putting the load balancer in front of databases. If you're going to do that, use a database proxy like Teleport, which is built for databases. So what else? Lambda, sure. What else? Rakesh, I totally expected you to say this instead of databases. What's the other way of hosting an application? Good. Yeah, containers, right? So ECS and EKS can be on the receiving end. The pods and EKS and the task and ECS can be on the receiving end of an ALB, right? As a matter of fact, with Kubernetes, it will actually spin up an ALB, right? Depending on what you like set up there as far as the ingress controller. So
Right. Well, but I still think of the target group being the underlying EC2 instance, though. The
that
target
is
group
technically
not made up
correct.
of the pods, right? The target group is made up of the instances.
Yeah. So to be clear about that, the way that works, Rakesh, is that even if you set up a ingress, it actually talks to the node ports, which in turn talks to the cluster IPs, right? So it's a little weird, but
yeah,
everything stacks on Kubernetes, and no one ever talks about it. It's not even in the documentation, but it's cluster IP, then node port, then load balancer if you have one, and then ingress. So it's really weird. I don't know why they don't put that in the documentation, but that's how it works. So you're right. It doesn't actually point directly to the containers, the pods. It actually has to go through the entire Kubernetes cluster. ECS doesn't work that way though. It does actually talk to the containers. Okay. You have an app with unpredictable traffic patterns that runs on at least 2 instances, and you want CPU utilization to stay around 75%. Which of the strategies should you use to be very flexible and make sure that you respond to that 75% that you're looking for CPU utilization? So a few things to key in on, by the way. Unpredictable means you can't use predictive. Just throwing that out there. Good. Dynamic has a version called target tracking, where you can actually tell the system is, look, I want you to keep CPU utilization around 75% plus or minus like 10%. And literally it will add and remove instances to make sure that CPU utilization across the fleet of systems hovers near 75%. It's called target tracking. It's a form of dynamic policy. So it's pretty neat. Target tracking is fun. You used to have to do that manually. So glad they added these things in. What service can invoke actions based on data from account resources and supported third management services? What did I say earlier was all about supporting third party like SaaS applications and whatnot? So we'll make sure this is clear. EventBridge is actually purpose built for third party systems, not CloudWatch events, not CloudWatch logs, certainly not CloudTrail, which is a security tool. EventBridge is built for third party reception. So make sure that's clear. Okay, which two of these are valid alarm states inside of CloudWatch? I'll give you a hint. OK is missing. All right, so insufficient data is definitely one of them. Alarm is the other. So it's alarm, OK, alarm, and insufficient data. Amazon had this funny story where they're like, well, we just want to make sure that you know that just because there's an alarm doesn't mean there's a problem. I'm like, I don't know what you're talking about, but if I have something in an alarm state, it needs my attention. I don't know if that's a problem, but it probably is a problem that needs my attention. So it's alarm and insufficient data and OK. They do ask you these questions on the exam, by the way. They'll say things like, you go to check on a newly started service and it says that it has insufficient data. What do you do? And the answer is give it some time to actually get some data, and it should go into an OK state at that point in time. Okay. All right, what is a typical use case for CloudTrail data? Remember, I said this was a security tool. What do we use it for? Give me two of these. Remember, it's a security and auditing tool. It's not a performance tool, right? So providing real-time observability of AWS resources, that's a performance function. Logging events for a particular service or application, that's going to be a performance function, right? That's state capture. That's performance. That's metrics capture, right? So it's going to be storing log data as a record of account usage, like to see who's using the account, and to capture root login failures, right? That's a security function. So remember, CloudTrail is for security. CloudWatch is for everything else related to performance. That includes logging, alarms, tracing, observability. All of that is CloudWatch. Okay. All right. That's the end. All right, so now we're doing lab 4. So I want you to go in and log into Quick Labs and go ahead and click start your lab just to make sure it doesn't expire, because the pre-warming sometimes expires after about an hour and 90 minutes or so. Here's what you're going to be doing. You are going to inspect the environment that has been set up for you. You're not going to create a launch configuration, because remember, launch configurations are deprecated. You're going to create a launch template. Then you're going to create an auto-scaling group. And then you're going to be patient. Did you hear what I just said? You're going to be patient. It never goes as fast as you want it to. And I don't mind you asking me. You can ask me all day long. It didn't frustrate me if you ask me. I just want you to know you're going to have to be patient. It's going to take sometimes up to 5, sometimes longer for everything to get registered in with the auto-scaling group. You're going to test your app. They're going to test the high availability of your tier, and then of your application tier, and then you're going to add a second database to the database tier, and then you're going to add another NAT gateway, and they're going to test the availability of it all. Okay. So that's what you're going to do. So we're going to be on lab 4, not lab 3, lab 4. And I don't believe there's an optional for this one. No, there's no optional for this one. So this one ostensibly will take 45 minutes. So we're gonna, grant 45 minutes for this one. So it's 11:30. So at 12:15, we're gonna check back in and continue on with our journey. So you get about 45 minutes to crack this one out. Okay. I'm here if you have any questions. Otherwise, let's get going on lab 4. Remember, detail orientation. Make sure you're following every step. Make sure you don't miss any clicks. If you find any confusing instructions, let me know. Otherwise, we'll go to it. Okay. All right. Here we go. Yeah, so we're going to cover automation, then containers, and then networking. We might get to serverless. I doubt it. But we'll see how it goes. We're not necessarily in a speed rush, so just want to make sure that we cover things thoroughly. Check-in question is, have you used any of these resource provisioning tools? And I think from what I heard, most of you have used Terraform, or you haven't used tools yet. So has anyone used CloudFormation? Or the CDK? What about any of the API code-driven stuff like Pulumi or Crossplane? No. Okay. Terraform is pretty much king when it comes to third parties, as far as but I don't really. At least I used to understand why, and now after having written most of my stuff in either the CDK or Pulumi, I really don't understand it anymore. You have to write a Terraform file for for all 3 providers, so it doesn't actually really grant you any special boon. It's not like you write it once and you can run it across all the cloud providers. It is a much more simple tool to use than writing code if you're not familiar with code, but it lacks all of the flexibility, the conditionals, the procedural flexibility, all of that, the repeatability even of writing things using like Python, for example. So Beanstalk, I don't know why Beanstalk's in there. Beanstalk is not infrastructure as code. It is a wizard for EC2, but I don't know why Amazon throws it in here. It's one of Amazon's oldest products. It's actually really good. It's good best practice wizard. It's not awesome. So anyway, automation. So, from my perspective and the perspective of many others, cloud made DevOps real. there was not going to be any automation of your end-to-end provisioning if you were going to have to crawl under a data center floor and run a cable. That was not going to happen. But now that somebody else has the responsibility and they're running the data centers and their hardware boundaries are ahead of yours, infrastructure as code, automation really starts to realize its full end-to-end potential. Because we can now automate the resources and everything, and we're not running into hardware boundaries because AWS is maintaining them so far away from where most of its customers are at. So we want infrastructure as code. We want to develop automated methods for spinning up and tearing down infrastructure like it's nothing. And we want repeatability in that. CloudFormation is the native, templating tool for AWS. It is proprietary to AWS, and it's a service that you can actually see as well. Now, it answers the questions, how can we simplify our cloud infrastructure build? Is it possible to manage multiple infrastructure sources as a single unit? And what's the best way to maintain and scale applications in the cloud, particularly the infrastructure that the applications sit on? So this is not just going to be a discussion about infrastructure as code. It's a general discussion about automation as a general rule of thumb. Now, I'm going to tell you, they keep throwing Beanstalk on here, and it is really just a wizard. It is an automated wizard that you can answer questions for, but it requires manual interaction. I do not consider that to be an automation tool. If you have to manually interact with a tool, it's not automation. You can't just push a button and go. You have to push a button, push this button, choose A, B, C, and D, hit this button, hit this checkbox. That's no different than, if you can only do it inside the console, it's not going to be automation. If you can do it through an API call or command line, sure. So CloudFormation and Terraform and subsequently Pulumi and CDK, that kind of thing, they sit in the do-it-yourself realm with a lot more control and a little less simplicity. So Beanstalk, the goal here is for Beanstalk specifically is to help developers deploy and maintain scalable web apps without having to worry about the underlying infrastructure. And this is great for people who don't know anything about AWS's infrastructure yet want its best practices. This totally wrecks infrastructure people. Not because it doesn't necessarily follow best practices, but it's inflexible, it's not infrastructure as code, and it doesn't meet all of, most of the cases that you're going to run into that most SREs, DevOps engineers, or cloud engineers are going to be able to do for you. But Beanstalk is a great place to start, not a great place to stay. Beyond that, we're looking at native tools for AWS, specifically the automation manager, systems manager, which has 17 subservices underneath it. There's CloudFormation, whose sole job is to ingest files and convert that into infrastructure. That's what CloudFormation does. So the user story with CloudFormation is that we want to basically have an environment, a service that we could submit infrastructure as code to and have it create AWS resources to our specification. Sorry, didn't mean to click past that. So we're going to talk about some of the components and some aspects to CloudFormation, right? Such as infrastructure as code, which basically says, can I code something, whether it's a YAML template or a JSON template or Python or whatever, can I code a file that I can then submit to AWS and have it create the infrastructure in question? So the way this works for CloudFormation is you submit a template, it gets fed into the engine spits out a plan, says, I'm going to create this, and then does it. Now you're not going to see that plan. It's not like Terraform where you get to Terraform plan and see what it's going to do. It's not going to tell you that. It's going to plan it and then do it, right? Now the benefits of this kind of thing is repeatability. You could take one template and you could have 7 different non-production and production environments, and you could use one template to define all that. Just one. The only thing that would change is the specific parameters, maybe the size of the environment, maybe the database you were using, So you get repeatability and reusability. The best high performing organizations in the world when it comes to doing this kind of thing are focusing on automation as a key goal. Doesn't solve everything, solves a lot of things. For example, if we have a template and we update with new security groups, that can get replicated across all of the systems as needed. Again, it just depends on how you want to set these things up. So it's YAML or JSON given to the service. The service translates it to an API request and then forms the resources that you need. What do these templates look like? Well, you've got a resources section, which is required, and you got to have an arbitrary name, which is what hello bucket is. You could call that, my bucket, your bucket, his bucket, doesn't matter. The type, though, must follow the CloudFormation syntax, which it defines AWS type, S3 object, and I want you to make a bucket. So the S3 service, and I want you to make a bucket object. And YAML, you can see it down below, same thing. So it doesn't matter what the name is. It could be, Kermit the Frog. It could be the name of the bucket in your template. But as long as the type is clear, Amazon knows exactly what you're talking about. This file can then be checked into a version controlled repository. And when someone else wants to make a change to it, they check it out, modify it, and then push it back in the repository. Something's watching the repository and then forces it to go back through CloudFormation and makes whatever change you recommend. That way, the version controlled file, you can always check and see who did what. Now, this makes a stack of resources, a CloudFormation stack. That's what you manage when you kick up a template, is the template generates a stack of resources. That stack, by the way, could have one object like an S3 bucket, or it could have 500,000 objects in it. By the way, stacks can refer to other stacks if you know the name of the stack. So you could have a security stack that sets the foundation, a networking stack that refers to the security stack, a storage stack that refers to the networking stack, and then a compute stack that refers to the storage and the networking stacks. In other words, you can make references to previous existing like CloudFormation stacks as long as you know the name or the ARN of the stack in question. You can also create change sets where you launched 5 instances and you want to launch 7. So you change the existing one and add 7 EC2 instances, and it takes a look at the differential and says, we're going to create a change set. Is that what you want? It's going to change a running stack at that point in time. CloudFormation has a bunch of really great features like this that allow you to increment changes over time. Now, I mentioned already that resources is a required section of the template, because if you're not creating anything, why even have a CloudFormation template? There are other sections you can add, though. Things like parameters, which asks you questions like, what availability zone do you want this to run in? How many EC2 instances do you want? Mappings, which are just key value maps. Conditions, which says, look, if the VPC starts with the name prod in the name, this is production, so I want you to launch 50 EC2 instances instead of 4. And then transform is for Lambda. I'm not really going to talk about that. That's deep meta on the thing. I'm surprised they actually have it in template. I don't think they had it last time I talked about it. And then outputs. Outputs is anything you want anybody who uses this template to know. For example, if you kick up a load balancer, what's the DNS name of the load balancer? Instead of having to go into the console, click on load balancers, click on the name and find the DNS name, the template can just tell you what it created. You created an S3 bucket with a random name. What's the name? So outputs are things that you want someone to know when they use your template. Now, I mentioned before is that you could have a security template, like a security stack. You can then have a base networking stack. Then you could have a shared services stack, and then you could have a back end, a front end, and then a defensive front end, like a security front end stack if you want to. In other words, stacks can just refer to stacks, and you can chain the stacks together. So they're like multiple horizontal layers that can just literally stack up to each other, and that makes a full product. That way, the operations team doesn't necessarily be in the networking team's, space and vice versa. You find this is a lot more rare now, but the teams are still dedicated to their particular silos. So CloudFormation allows you to do this kind of stacking with multiple resource stacks. Now, Amazon realized that sometimes writing these things from scratch is hard. So Amazon came up with a solutions implementations portal that allows you to solve common design problems and build faster using the platform. The solutions implementations are all vetted by AWS architects. You can download them off of AWS's website. And they are, reliable, performant, cost-effective, et cetera, et cetera, et cetera. And you're going to get charged for the resources as they're created. But the point is that these CloudFormation stacks are best practice stacks. And let's see. Let's go take a look and see if we can find this. So you just browse and look for the things in question. For example, here's a limit monitor, right, that automatically provisions necessary to track resource usage as you approach like certain limits. Here's a centralized logging option, burst rendering, right? There's just hundreds of solutions based on whatever you're looking for. You just click on get started. And then what you're going to do is you're going to like look at the area that may make sense to you. For example, let's say you're working predominantly in retail. You can go into the retail section, be like, okay, what if I need a chatbot for AI? Oh, let's take a look at this. Here's Lex. Oh, there's a serverless bot framework. Let's take a look at that. This shows you everything that this will create if you were to actually run this particular CloudFormation. And this is out on GitHub. And this is using the CDK solutions constructs to make this work. So it's using CloudFormation. So the CDK, by the way, generates CloudFormation, right? And so this will show you how like to deploy it, for example. So you can literally take this CloudFormation, load it into your system, and it will recreate this entire setup for you. Now I have to say, where is that exactly? This particular one, again, was probably a bad example. Let's see what's out there. Oh, this is all CDK stuff. So you need the CDK to generate it. I can tell by looking at it. Huh. Shell scripts. Here's the solutions helper. Yeah, this is all actually using the CDK. The CDK, by the way, requires you to initialize the CDK, run the CDK synth command. It actually generates the CloudFormation at that point in time. And then you can do CDK deploy and it will literally kick it out to your system. So these serverless solutions implementations are where you can get these best practice, either CDK defined, SDK defined, or CloudFormation defined. They're typically CDK defined now. Previously, they were like raw CloudFormation, but people are using the CDK more and more and more. Now, what is the CDK, since that was what we saw most of the examples in? It basically allows you to use any of the supported languages in order to generate your CloudFormation templates. And then you just save your CDK code. You just check that into repository. And the reason you would use the CDK over just writing raw CloudFormation is it takes like 1/10 of the code to do it, because it converts it all in the CloudFormation for you. So you don't have to write all the extraneous CloudFormation and check the syntax. The CDK will convert it all for you. And I haven't had one mistake or one bug inside the CDK to date. Doesn't mean I haven't heard of bugs, but I haven't experienced one. if you want an example or of like a workshop, I think I might have shared this already, but there's a CDK workshop. For example, if you were doing the Python version of this, this is where you would do the CDK init, for example. This is where you would actually like set up what, you know, you initialize with a Python language. You do some Python stuff. We're gonna ignore that. And then this is just them using code. Here's the app.py, which is basically just like kind of initiating the CDK stack. And then here's the main file. And notice that it is defining an SNS topic. It's defining an SQSQ, and it is subscribing the queue to the SNS topic. Interesting. So just know this workshop will walk through a bunch of different pieces around the CDK if you want to dive into that a little bit more. But that's what the CDK does. Is it provides a code way of writing CloudFormation templates. Now, contrast that. That's all infrastructure as code. That generates whatever resources you want. So the CloudFormation, by the way, supports almost every single service AWS has. There's probably like one or two exceptions. Like QuickSight, for example, is a pain in CloudFormation. But almost everything else is in CloudFormation. But what do you do if you need to manage fleets of EC2 boxes and maybe check on overall systems management for all the services you have active? Well, this is where Systems Manager comes in. And I mentioned before that Systems Manager has like 17 subservices. That's the last time I looked. Let's go take a look now and see how many services it has underneath it. Excuse me. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Well, that's not really a service, actually. That's just a document repository. So 20. That's System Manager. So Systems Manager has things like the Session Manager, the run command. You can distribute patches. You can distribute software. You can manage an entire fleet. You can do an inventory of all software. You can check all the operational security compliances. You can automate documents using this document repository. They get pushed out to every system that you specify. You can also have a change calendar to track all changes into your environment, as well as set up maintenance windows to say, look, I don't want you to do backups or any kind of other document execution during this time frame. That's what the maintenance windows is. It's also got a parameter store, which is very similar to a vault, except it's not inherently secure. Some application configuration services, an application manager, which also does some appvig and deployment kind of pieces, an incident manager, and you can ignore CloudWatch dashboard. So I guess technically it is 19 services. And then there's Op Center. Op Center and Explorer allow you to track all the operational incidences in your environment, and you can respond to them, remediate them, mark them as complete or not. So Systems Manager is a really robust tool for provisioning, configuration management, compliance management, and some monitoring. It's got a bunch of really like great and positive attributes as far as like helping with security and helping to manage pretty much anything, improving observability. And again, it's got like all this stuff in it. So at least 20 services, depending on how you define them. The vast majority of the biggest ones are actually related to managing virtual machines. So you're going to see that fairly consistently. So here's a quick knowledge check, and then we'll scope for lunch. What is a CloudFormation stack? A, B, C, or D?
We can't hear you.
Thank you. The CloudFormation stack is the actual resources, the service objects that are created by the template you submitted. But remember, a template must always have at least one object definition in the resource section. If it doesn't have a resource definition, it's not really doing anything. So based on what I just said, what's required in a CloudFormation template? Which of these is required? Yeah, right. Resources is required. Okay. So which of the following are using the benefits of the CDK with CloudFormation? Why would you want to use a programming language with a CDK with CloudFormation? What would be the benefit? Good. Yeah, A and C, right? I mean, let me be clear. When you use Terraform, you are learning HashiCorp's proprietary configuration language. When you use CloudFormation, you are learning AWS's proprietary configuration information. When you learn anything that like allows you to write in your normal programming language and then gets translated, that it is taking the responsibility of translating those objects into the things that you need. So it's a very different beast in the sense of that you're defining some code, it's defining objects, and those objects are getting converted over. It's a very different thing than like defining a flat file and just saying, look, I gotta have every single thing delineated in here. Again, you're gonna write 1/10 of the code if you do it with the CDK. If you do it raw, you're gonna write all of those lines because CloudFormation won't even function without everything being defined. Good. All right. That's the end of module 8. Does anyone have any questions at all about either Systems Manager or CloudFormation?
Yeah, one of the big reasons I like Terraform is the community support. There are so many community defined modules, and obviously if you have questions, that's a whole HashiCorp blog thing where you can post questions, or of course Stack Overflow is a big community. Does CDK have Python specifically? In your experience, do you know if it has good community buy-in and support that way?
Well, the Python community was the first to embrace any of the SDKs for AWS. So I think by proxy, because the SDK was embraced so strongly, CDK is embraced strongly. I wouldn't say necessarily though that the CDK community is as strong, if not stronger, than Terraform. I would say the Terraform community probably is stronger.
Right.
Just because, right, it's been around for longer at the very least, right?
Yeah.
CDK is relatively new. It's 2 years now. CDK is open source, but AWS is the only one who's adopted it. So I would say that, Terraform probably has broader community support with more depth over the last 5 years that it's been available.
Right.
The CDK, probably only has 2 years of history. That didn't stop me from being able to find answers to problems when they arose.
Sure.
But I would say that I probably find them quicker with Terraform than I do for the CDK.
Yeah, that's what I expected. All right.
Yeah.
I don't know if it's changed since I last looked, but to build on that point, when I was working with GCP, there's a third-party GCP Terraform module that's actually like more stable and frequently updated than their official one.
Yeah. That's my, the proliferation of modules inside of Terraform for AWS sometimes was distracting. But I honestly, for the most part, even the community user modules that I've used for Terraform, I usually don't run into like major bugs or issues with them. It's just more about learning the syntax. So I haven't experienced that with GCP. but with AWS, it's been pretty stable. My only issue is that there were so many, and some of them were abandoned. But and by the way, if you use the CDK, there's version 1 and version 2. Please use version 2. Version 1 was less than ideal, to be diplomatic. So, okay. Well, that actually is the entire like module for the automation section. It's just really just kind of a skim. They do a lot more of the automation building inside of the system operations on AWS class, because that's where most of the building is going to happen. But they want you to be aware of it because systems manager is like the bulk of that class, honestly. But as an architect, it's good to know how to build. All right, it is 12:59. So we are going to stop and take our lunch breaks here. All right, the next thing we're going to cover is containers. Again, another kind of like shorter module that we're going to spend time on, and then we're going to roll into networking too. So unless anybody has any questions. Okay. We'll finish out containers, and then what we'll do is that we will do some question review. So we'll do a little bit of exam study for monitoring automation and containers kind of like all together. And then we'll roll into networking, finish out networking too, and then we'll go from there. Okay. So 12 Central, 1 o'clock Eastern, come back at 1 o'clock Central, 2 o'clock Eastern. So in about 60 minutes, we'll see you then. Enjoy your lunch. Try to get away from your computer. Just give your brain a break. We'll see you in about 60 minutes. Okay. Okay. Here's an interesting question. I think I asked this before, and I think Rakesh was the only one who said that his stuff was running in ECS. Nobody else is running containers, to my knowledge, correct? Here's another question. Has anybody else built a container before? Like run Docker build or build a build or Podman build or anything? Okay. Okay. So they're going to talk about where you can run containers in production, but they're not really going to talk about what containers are per se. So we might back up for that. So here's the call to action. Call to action is that, right now, a quarter of their workloads run on containers. They expect it to grow. And that's probably aligned with the industry. The industry is predominantly everybody's heading towards containerization just because it adds so much ease to deployment. So repeatability, all kinds of stuff. It's shocking the benefits when you get a common package format for your application deployment. Basically, it's shocking how like much things can be more easily standardized. So in this particular case, the call to action, they have a bunch of legacy applications that need to be re-architected to run into containers. And so they're gonna expect a huge expansion in the demand for container infrastructure. We also want to talk a little bit about microservices and containers, which go together like peanut butter and chocolate. You can enjoy them separately, but microservices and containers do actually go together really well. So then the questions that we're looking to answer are, when is it better to use containers for your compute needs? What solutions do they have to ensure that the containers applications are highly available and scalable? And is there a way to build infrastructure agnostic portable application environment that could, run regardless of whether it's an AWS or not? So we'll talk about that. To kind of stick with our reference architecture, this is where potentially like the app servers could live instead of them running in apps inside virtual machines. They could be containerized apps, either running as tasks or as pods, either on ECS or EKS instead. To be clear though, containers a container is nothing more than a packaged application. That's it. It's application virtualization. That's all it is. It's a standardized application format. Think about shipping containers, right? Before shipping containers, what was that, the 1950s or something like that? Before shipping containers, everything was all over the place. But if you have now the infrastructure to handle a standard shipping container, you don't care if there's bananas, Intel processors, or tires inside. You can manage that container. You can take it and put it on a truck, put it on a ship. You can store it in the shipyard. You know how to manage and interface with that container, regardless of how messy the contents are inside of it. That's all really containerization is you are simply standardizing the interface, the packaging around, Ruby, Python, doesn't matter the language. You're simply just putting it in a standardized packaging format. And then what happens is that when you then take that container and put it either onto a container orchestration system like Kubernetes, it knows how to run that container based on whatever, definitions and questions that you answer, how to scale it, how to keep it alive, what the definition of healthy is, and what to do if it fails. It can auto respond to failure. Nothing's a panacea. Cloud wasn't a panacea. It didn't solve all our problems. Neither does containerization. And certainly Kubernetes doesn't either. But they are useful kind of moves forward when it comes to being able to create portable, abstraction layers that allow us to scale and respond and do all this stuff a lot easier, right, than we used to in the past. So what we're going to talk about then is we're going to talk a little bit about microservices, then we're going to talk about just a little bit about containers, and then about container orchestration or container services. So my manager told me we should use microservices, but I don't know why. That's not a bad statement, actually. Most of the time you come across these concepts in webinars and conferences, or your peers will talk about them, but it's like, why would we do this? Well, microservices is kind of arisen as a pattern, mainly because the days of the monolith are over in terms of one big massive app that is able to scale to millions of users. Because we're now in the age of internet, especially if it's an app that has any kind of social aspect to it, you're going to need to scale these apps to millions of concurrent users at any given time. Imagine the scale of for example, Snapchat or Facebook or even Netflix, right? Their infrastructure has had to become incredibly distributed in order to maintain all these services in concurrency and at scale. And so part of this is that there are certain aspects that AWS and others consider to be part of what's, would be considered cloud native build patterns. One of those is loose coupling, meaning instead of having for example, your web servers hard coded with all of the existing application servers, or even using a DNS name, which DNS is great at traffic redirection. It is horrible at traffic distribution. It's a big difference, right? It does not actually distribute the traffic. It just resolves it towards certain directions. And depending on the caching and whatnot, it's not that great really at traffic distribution. It can direct, but it doesn't really distribute very well. So for example, throwing a load balancer between your web servers and your app servers and just having all the web servers talk to the load balancer, which in and of itself is a virtual device, and it can be the front end to go to the app servers. We know this works because almost every website that we go to across the internet, you're not going straight to a web server. You're going to some kind of load distribution system, like a load balancer, which then is sending you to servers on the back end. So adding in these abstraction layers like a load balancer, right, to do redirection, or adding in like a physical hardware virtualization layer like we did with virtual machines. We add these abstraction layers because they add complexity, but what they get us is they give us flexibility, particularly around scale. They give us the flexibility to scale when we add these abstraction layers in there. But again, of course, the cost is that it's complexity. We've now got virtual machines sitting on physical hardware with an abstraction layer. And now inside those virtual machines, we're now running another abstraction layer with Kubernetes, and it's doing application virtualization. Why would we do that? It sounds like an inception style model that just has added complication to the equation. But the benefit of that, if you can endure the complexity, because maybe you've got software that will help you eat the complexity, you get the benefits of being infinitely portable. And then from the customer's perspective, you've got this ability to scale that you have never seen before. Containerization, for example, imagine you are scaling an application instead of having to scale an operating system. The footprint of an operating system being scaled and just an application being scaled is vastly different. And so this kind of loose coupling, as an example, is a pattern that you want to follow whenever you consider how you design your cloud native applications. Microservices fit this because with microservices, what we're doing is we're taking this single monolithic code base that had all aspects of the product contained inside this single running application. And we're now splitting out all of those product concerns, all those business concerns, into separate, independently scalable applications. What's the cost of this? Complexity. These applications now have to talk to each other across the network, preferably through well-known and published APIs. But now when I need to scale topics, instead of having to create a complete copy of the application every single time, I can just take the topic service and I can scale out the topic service. It's more granular, more efficient. Again, more complex, absolutely. But software like Kubernetes and underlying infrastructure components like cloud have evolved to eat this complexity for you. The thing that's hard for us to let go of in this particular case, Kubernetes kind of being a great example of this, is if you've been in the industry for 25 years like me, control becomes a problem. You don't want to let it go. And so it's one of those things where, you don't want to let go of control. The mindset is a little scary because we're unfamiliar with the topics, but these abstraction layers can eat this complexity for us if we understand a little bit about how they work, how we can influence them in the ways that they can work for us. And we get comfortable with the troubleshooting process because this complexity also increases the complexity of troubleshooting. So the more we know about all these complex layers, the easier it is for us to deep dive into them. But microservices, and probably one of the best websites to talk about this complex topic, is that there's a couple of characteristics for a microserviced application. One that has been split from a monolithic code base into these separate, distinct services that make up the entire product, is that one, there's a separate code base for each of the services, so they're not just one code base. Two, each of the services speaks across, through an API to each other. So they're independent in that way. So independent code base, talk to each other through APIs. So if messages needs to get user information, it actually talks to the user service to get information through the user API. If topics needs to get something from the messages services, it talks to the message services API. And then the second characteristic, other than using APIs to kind of talk to each other for a microservice setup, is that these are also independently deployable. So independent code base, independent set of APIs, also independently deployable, which also makes them independently scalable. So, now you've got, instead of this single code base that munges together all these different areas of product concern, you now have product scoped services with areas of specialization. By the way, this also means that the user service could be written in Python, the topic service could be written in Java, and the message service could be written in C#, because we're talking through well-known and well-published APIs. We're not talking inter-process memory communication like we are with monoliths. So there are other benefits in addition to flexibility of deployment and flexibility and independence of release times, you get flexibility in terms of tech stack as well. I do want to point out that this is a topic that is a rabbit hole. So the best person I've ever seen explain microservices is Martin Fowler. And I actually had a chance to work with him quite a bit at ThoughtWorks, actually. So so he has a guide to microservices, which includes a series of articles about like when to use a microservice, when should you not use a microservice. So if you find yourself in the journey of going from a monolith with a microservice, right? Here's a great set of articles to take a look at because it's a topic you want to dive into. Now, when you architect for microservices, you know, the cool thing is especially since almost everything's web enabled now, right? You're talking about just an expansion, you know, over and above on service oriented designs, right? This is just a leaner way of defining SOA, which we've been using since the 2000s. You know, API first is the focus. CI/CD is considered to be essential for the automation of the delivery of all these various services. You know, I've seen people use Agile and not use Agile, or fragile, you know, waterfall. You know, opinions vary about Agile. Bottom line is that, you know, some agreed upon method of work where it's done in discrete batches and the work is, you know, obviously somewhat scoped out ahead of time, weighted, you know, some form of weighting or estimation is done against it. Anyway, that's a whole other topic for another time. But here, for example, if a single product has, you know, a user service, a topic service, and a messages service, just know that that application load balancer, the reason those rules exist inside of those listeners is so that if someone comes into example.com/users, they're going to go to the users microservice and talk to its API. They go to topics, they'll go to the topic service, messages, you know, et cetera, et cetera. And there could be one where just example.com just goes straight over to the web server so it can present web pages. It does not actually going to talk to the API. And then if you add additional microservices like /profile and /credit card and /bill, you know, whatever it is, you can just keep adding those microservice paths in there, and they can be all independently deployed into their own set of regions and availability zones. Now, I will say for technical purposes, they're all going to be in the same region. You don't want one of your services off in Tokyo while the rest of it's in Sydney. Just keep it all in the same region. But that doesn't mean, by the way, that you couldn't do global replication where you have one set of services in Sydney and a whole other copy of a set of services over in Tokyo. You could do that easily. So application load balancers, you know, do the pathing and routing necessary. You could also, by the way, use an API gateway, which if you're doing APIs, typically is a better option, just to throw that out there. An application load balancer, if you're fronting APIs, you typically actually just want to use an application load balancer. I'm sorry, an API gateway. This is really for web traffic, but they use this as an example to give you an idea of how that functions. Here, by the way, /users could go to a Lambda, topics could go to EC2, messages could go to an ECS cluster, you know, /billing could go to an EKS cluster. Again, there's no one size fits all approach as it states in the slide, right? So you can approach this, you know, architect it as you see fit. Now, here's the problem. I keep mentioning this, is that the cost of adding these abstraction layers, whether it's in design like microservices or adding in like a container, like process virtualization, like, you know, taking your Java app and putting it into a container and then throwing that out onto ECS or EKS, like one of the container orchestration services. How in the world do you track the user experience from end to end? Let's say the user comes in, just follow me for a second. User comes in, right? And let's say they hit some application code and that's on S3. Like that's a client side S3 execution. They pick it up off of S3, but maybe before that, it even hit CloudFront. because it got some images, right? And then it hits Lambda, right? And then what happens is then it talks to DynamoDB, and let's say it talks to an RDS database. How do you know if you're having performance issues, how do you know where it is failing in the journey, right? Well, this is what tracing solves. And tracing, open tracing in particular, is part of the CNCF. If you're not familiar with the Cloud Native Computing Foundation, by the way, just as a little side note, which Amazon, Microsoft, and Google are all part of the CNCF, the Cloud Native Computing Foundation is pretty much the shepherding open source body for all of the cutting edge, and some bleeding edge projects that are out there. So if we go look at the brain, you know what, I'm just going to type it in. If we go to like the landscape map for the CNCF, this is a list of all of the CNCF projects that they manage, which includes things like Helm, Kubernetes, etcd, which is a database, Envoy, Linkerd. These are all like the graduated, running, like emerging and sandbox projects that they're managing. The reason I mention this is that containerization, of which the standards are actually like kept here at the CNCF, they're all defined like at this landscape. So tracing is actually part of the CNCF over in the where are you? The observability analysis? Nope, there should be. Give me just 1 second. Open telemetry is part of it. Hold on. And these demos have not gone well this these last few days. Things have been moved around. There used to be an open tracing agent here, and I'm kind of like lost it. I don't see it. Open tracing backstage. Nope, there's the operators framework. Jaeger is what I'm looking for. I don't see it here. Oh, never mind. It's right there in front of me. Jaeger. So it was actually where I thought it would be. So Jaeger, for example, is an open source implementation of tracing, which allows you to trace end to end a user's journey through all the services in your infrastructure. X-Ray is Amazon's service. It's part of CloudWatch that allows you to create a service map of a customer's journey through all of your services, including, by the way, the latency and transactions per second for each of those services. So if you're hitting S3, Lambda, then DynamoDB, just because you have a simple app, when you enable X-Ray, it will run a trace through these segments through every single part of your infrastructure for that particular workflow. And it will show you what the performance is for the customer for every single segment of the journey. And it'll let you know if you have any problems. So it provides an end-to-end service view of all the services in a particular like customer journey. And it creates a map, and you can interact with the map inside of CloudWatch. It creates what's called a service map. So you can analyze issues, you can see problems, you can actually click into it and see logs that are hosted in CloudWatch because it's part of CloudWatch already. So X-Ray is a really cool tool that you can turn on. Now, if you've used New Relic or AppDynamics, Dynatrace, or even like Datadog's like APM tools, then you're familiar with this kind of thing already. It works very similarly. It basically shows you at every stage how the applications are performing for the user. X-Ray is a pretty cool tool in that it does actually integrate natively with all of AWS's services. So when you need to do like deep level troubleshooting, it's really good. Amazon, by the way, has also added a couple of other new things recently to like where you can tag the front end web pages and see how that session runs through the entire environment. So they've added other aspects to tracing inside their systems as well. So that gives you a general idea around not just like microservices, but also how to troubleshoot these now distributed complex suites of microservices. Now, microservices is a design architecture that says we're going to take our monolith and split it into a bunch of product services. Benefits are tremendous, but we said before, complexity can be a problem. How do we like abstract away that complexity? Is there a way to minimize it reduce it? What do we need to learn in order to be comfortable with the increased set of complexity? Well, part of that is, before containers came out, particularly Docker, and let me be clear, Docker is to containers what Kleenex is to tissues. Docker is just a flavor of containerization, arguably the most important flavor, because Docker, the company, was kind enough to basically give Docker to the entire world. So, which was a good move on their part, because otherwise we would have had non-standardized containers, which would have been a huge problem. It would have added diverse complexity, right, to the IT landscape instead of a simplified complexity, which I know that sounds like an oxymoron, but it was better this way. So before, you had to figure out how to take the jar files and whatever wars and years we were using back in the 2000s, and you need to figure out how to do that with the zipped Python that you had, or maybe you had created a Go binary, and what framework for deployment we're going to be using. It was kind of all over the place. Now what happens is that the developers can define how they want to build and structure their app to generate an artifact, so an application artifact, which then gets stuck inside of a container. It can be part of the container build process, by the way, or it can be outside of the container build process, and all you need to do is just copy the artifact into a container, which, people overlook that. They think they have to build everything inside of a container. You don't have to do that. You could literally just copy your app over to the container. It could be like 2 steps. You don't have to run Maven inside of the Docker build file. You could literally just copy your jar file out there and be done with it. That all being said, Docker containers in particular create a standard that is going to live, forever. It evolves, but it was the basis for everything that we do now. So now all you need to do is you just need to know how to handle these containers. That's it. If you know how to deal with a shipping container by land, by sea, by air, you now know how to handle these containers, because they all have a standard interface. That's it. So inside these containers is a code, typically some kind of runtime engine, like it could have a JVM or whatnot in it, and anything the application needs to run. Note that these containers, the only thing that the container gets from the host it's running on is it talks to the kernel. So a little bit of a caveat. If you build your application for Windows and you put it inside of a container, that container has to run on Windows. Now, it can be a Windows virtual machine, but it's still going to need to run on Windows. If you build that container for a Linux x86 environment, because you put a Go binary in there that's compiled for x86 Linux, it's not going to run on an ARM-based Linux system. It was built for Linux x86. So that's why, by the way, containers are nothing more than application virtualization. You do not have an operating system inside of these containers. People are like, well, hold on, wait, Michael, hold on. I have stuck an entire Ubuntu installation in a container. Yes, you did. You stuck all the binaries for Ubuntu inside the container, but when you go to run that container, it's using the kernel of the host. So all those binaries that you stuck in there that you were for Ubuntu, the reason they work is because the kernel you're talking to on the host supports those binaries. So again, this is application virtualization. There is no operating system running inside of these containers. So when we talk about running a container, you're running it on top of a virtual machine that has an operating system in it. And these containers run as isolated jailed processes inside this operating system. That's all a container is. It is a jailed virtualized process. So by doing this, by the way, this container will now run anywhere. If it's like built for Linux x86, if it has a Linux x86 kernel that's been built in the last 6 years, that container is going to run. It doesn't need the JVM from the host. It doesn't need Java from the host. It doesn't need any libraries from the host. That container, as long as that kernel is container compatible, that container will run on that system. So this is, a lot of portability. Because it doesn't matter then if it's Red Hat or Ubuntu or Debian or SUSE, no one cares. Does it have a kernel that's older than 3.10? Oh, it does? Good. Well, if it was built for your processor, it's going to run. And by the way, when you download these containers, the software, by the way, automatically checks to see what processor you're running, and it downloads the appropriate container. If it doesn't exist, it'll tell you. Now, these containers, by the way, take seconds to spin up. You're not spinning up an operating system, so you're not going to wait 30 seconds to 10 minutes to boot up. You want to stand up Kafka? It'll take 60 seconds to stand up Kafka if it's got a ton of data in it. If it has no data in it, it'll take 2 seconds for you to stand up Kafka. Imagine you're sitting there waiting to respond to a fire because all your web servers fell over. You've got plenty of capacity, but it takes you 30 seconds to 6 minutes to stand up a web server. But instead of using virtual machines, you decide to use containers. You can start Nginx up in about 3 seconds. And it's ready to go. That's with configuration. So these containers boot way faster than an operating system, like a virtual machine, because all they have is the application inside of them. So then how do containers and microservices go together if, containers are these small, like isolated processes? Well, what happens is that instead of having this monolithic set of applications where one handles reporting, one handles the UI, and one handles ordering and one handles marketing, instead of having these 3 different apps, there's a lot of duplication here. So maybe the UI stays the same, but now when the reporting team needs to grab inventory information, they just go talk to the inventory container. Now, when the ordering UI needs to get some mailing logic, it just goes and talks to the mailing logic service. And these, by the way, could all be stacked on the same server because I don't have to worry about collisions anymore. I don't have to worry that inventory is running, Java version 11 and order history is running Java version 13 because they are isolated from each other in their own process and memory space. So there's no collisions between JVMs or shared libraries. None of these are sharing libraries with anybody else. They're all independently packaged and contained. So this is an ideal choice for microservices because they're scalable, portable, continuously deployable, exactly the way microservices are designed for. Now, I keep mentioning this, is that the cost of doing this is a level of abstraction. But the cool thing about containers is that in a certain degree, they kind of simplify things. So let's talk about this a little bit. So this is the way we've done it for a long time, since 2002, when I don't even remember when like the VMware desktop first came out, ESX desktop. I can't remember, I think that's what it was called. 2002, I think it was. That's when we started getting these isolated virtual machines, right? That we could launch independently. And the virtual machines could be Linux, Windows, whatever, right? And they sat on this virtualization platform, which sat on top of an operating system. Now, this operating system now is munged together, and this is called a hypervisor, right? Where you got the virtualization platform and the operating system just kind of munged, right? It's a hypervisor. That's what we call it now. So what happens is that with containerization, we're getting rid of this guest OS. We're saying, look, I don't need to replicate this guest operating system anymore. And instead of a virtualization platform, I'm now going to run a containerization platform because, and this drawing is a little strange because this is not actually how this works. This container is now isolated. So there's this implication of shared libraries, by the way. You wouldn't do that. I don't know who drew this, but that's not how that works. You're not going to share libraries across containers. That's not going to happen. There's no reason to even have containers if you're going to have dependencies like this. So this is all isolated now. So this container operates independent from these containers. Now they might talk to each other, by the way, because remember, in microservices, everything talks to everything else through APIs, right? So these containers, being the repositories for these microservices, they might be talking to each other, and that's totally fine. But they're talking through APIs. But notice these containers do not contain an operating system. The only operating system is down here on probably what is a virtual machine, but that's it. So every time I copy one of these containers to scale it, I'm not copying the operating system, which means less attack footprint, less licensing, less complexity, less management. All I'm doing is scaling the application. I'm not scaling the virtual machine anymore. It also means it's lighter. It's going to boot faster. Containers have been around since 2013, 2014. Kubernetes came out in 2015, if I remember correctly, July of 2015. I think that's when its birthday is. And so we're now, 7 years or more into this container journey. And what we're finding more and more is that, probably, again, I want to be very careful about like making any statistical statements because I just think it varies so much. But we are seeing this increasing trend more and more where containers are just eating all deployment methodologies. Like people are just going to containers. Even conservative companies, which would typically eschew like, that kind of migration. I would say probably if I were to guesstimate, it looks like 2/3 of all the companies we're encountering now are running the majority of their workloads in containers. And that's only increasing year over year. So, so it's something to be aware of, especially, in the industry as a whole, and just know that if the benefits make sense to you, you do it. But like I've got friends who run medium-sized like educational companies. They are just now getting to containers, which is totally fine. Because there was no benefit for them to do it prior. But now that they're kind of re-architecting and incepting new products and thinking about how to scale to university size users in a different way, they're looking for new ways to solve new problems, right? So one last little slide about the concept, just to make sure that containerization comes home. Again, see, we got a virtual machine. Here's a hypervisor. With containers, the only thing we need, and it says Docker engine, it actually needs to say a containerization engine, because not all engines are Docker. That's just the flavor of containerization. This is how this works, right? You got individual containers now running on top of, a virtual machine, increasing density, increasing ROI, reducing total cost of ownership. And it says over here, containers are isolated but share OSs and where appropriate bins and libraries. No, do not do that. You are not going to share binaries and libraries among your containers. They need to be independent from each other. Otherwise, you're going to create dependencies that are going to cause problems. Okay. Questions about this before we talk about containers on Amazon?
No questions.
Okay. So let me ask you this. If someone said to you, hey, can you tell me what containers are? Based on what I've just said, is there like a couple of words or a single sentence that you could say that would define what containers are?
Portable packaged applications.
Fair enough. That's actually well said, Mike. Perfect, right? Portable packaged applications. That's it. App virtualization, process virtualization, portable packaged applications, standardized application packaging.
Along with its dependencies is the only thing I would add.
That's a great addition, right? In other words, everything you need to run the app is in that package. It's in that standardization. It's in that virtualization container. Good. Okay. Perfect. I just want to make sure the concept is clear. Okay, so let's talk about this in relation to EC2 or other services. So for example, all right, So here it would be the kind of like the traditional, see the old way. Wow. This is the traditional way in which we do it, right? We run apps with their libraries on top of a guest operating system, and that's its own virtual machine. Nothing wrong with that. Be clear about that. There's nothing wrong with doing it that way. Now, over here, though, we've got a guest operating system and someone's installed Docker, right, which is a containerization engine, and they've put a single container on here, which you typically wouldn't do, but maybe you're just messing around. Nothing wrong with that. And then over here, they've got another single virtual machine. It's got 2 containers on it. Now, typically, just to say this, you're typically going to run dozens of containers on a single virtual machine. But as you well know, it depends on how big the virtual machine is. If it's got a gig of memory, the answer is probably going to be no. If it's got 32 gigs, it's a resource. It's a math problem, right? How big are each of the containers? Are they eating a gig, half a gig, 2 gigs? So, it just depends on how big your containers are, what they're doing, what the load is, what the CPU load is, what the networking load is, et cetera, et cetera. The problem here is that who's going to manage all these apps at scale? What happens when, like, I did a proof of concept, right, for the NFL? What happens when you get to thousands and thousands and thousands, tens of thousands of containers? Who's going to manage that? You're not going to manage it. You can't do it manually, right? So how does this happen? Well, you're not going to run it on EC2. And the reason is that once you run it on either ECS or EKS, and I want to be clear about something. Can anyone take a guess for me and tell me the number of services, the number of ways that you can run containers on AWS? Does anyone know the number? Anyone know the number of ways that you can run containers? So this shocked me when I found out. There's actually 33 ways to run containers on AWS. Everything from IoT to running it in batch in the AWS batch service. There's 33 ways to run containers. The only reason I know this is that gentleman, Corey Quinn, who does Last Week in AWS, he wrote a funny blog post called 17 Ways to Run Containers in AWS. And then he wrote another one called another 17 Ways to Run AWS. And later AWS came back to him and said, hey, by the way, one of the ways you mentioned is actually a duplicate. And he was like, I stand corrected. I'm sorry. It's not 34. It's 33 ways to run containers on AWS. So, but let's be clear. Officially, in terms of services that are designed to host containers at scale, there's 2. There's 2 of them. So let's talk about what those 2 are, because the other 31 don't really matter, honestly. Okay. First of all, I would be completely remiss if I did not first tell you that in order for a container to be deployable, you have to make a container image. That shouldn't be a surprise to anybody. Just like deploying a virtual machine, you need to have a boot image, like an AMI. You need a bootable copy of some kind of hard drive or some kind of package before you can boot virtual machine. Same thing with containers, and they are stored typically in what's known as a container registry. The most popular container registry in the entire world is hub.docker.com. Now, Amazon, in order for you not to have to keep storing things on Docker, has its own container registry, so you can keep copies of your deployable applications close to your cluster. And so they have the Elastic Container Registry, which is used to host repositories that contain images like your latest Redis database or your latest Nginx, right? Now, just like AMIs, these images are usually vetted by security, scanned by security, vetted by operations, scanned by operations. Like, they're like approved. You will not be pulling these just off the internet and then running them in production. That's a no-no. Right? People have been hacked that way. Don't do that. Now, Once you've got your image built, your container image built, and it's in some kind of registry, preferably like a container registry, the ECR, you can then use either ECS or the other service, EKS, to run these applications. And all you need to do is define the characteristics of your app, what image you want, what version do you want of your container image. And you can either launch it on EC2 virtual machines that are managed or unmanaged, or you can run it on what they call serverless, which is also code for Fargate. Remember how I kept saying that Fargate was not a separate product? Fargate does not exist outside of ECS and EKS. And probably Aurora. Right, but it's part of other products. It's an enabling service. You can't find it in the console. So you can actually launch things serverless where you don't manage or see the servers at all, or you can manage it where you can launch it where you see the servers, but lightly manage them, or you can launch them where you have full control over the servers. ECS, excuse me, is proprietary. This is what Amazon came up with before Kubernetes hit the mainstream. And man, I could have sworn it was just like a year or two before, not 4 years before, like they're claiming. I don't know. That's strange. Maybe they started working on it back in 2014, but I'm pretty sure they didn't have it out. So ECS is an option. This will run containers at scale, but you will learn Amazon's very simple yet proprietary way of defining tasks and running them. So when you first get started with running containers at scale, this is a really great place to start. You know, for example, API users, API topics, API messages, you know, you can now run those as separate tasks / containers inside ECS, and it will go to whatever instances it needs to, right? In other words, it will find all the running instances of messages, and it will talk to whatever one that is active that it needs to talk to. It will talk to whatever active container of topics that it can find, right? So it's going to find the containers, no matter if you're running 5 or 50 of them, it's going to find them. This is all set up through service discovery and all kinds of stuff that we're not necessarily going to get into. But so if you have, 15 EC2 instances, it knows where everything is. It is able to find the containers no matter where they live. Now, all you do, by the way, is you say, look, I want to run 2 instances of container A and 3 instances of container B. And you just say, I want you to schedule it. And the scheduler does the work for you. It figures it all out and schedules it out on this, whatever cluster you have. If you've got 2 nodes, it's going to try and split them evenly. If you've got 30 nodes, it's going to try and spread them out across all the nodes. Excuse me. Sorry, I don't know why I started coughing. I apologize. So just know that it's going to handle deployment for you. And by the way, if one of these tasks, if these containers fails, it'll automatically restart it for you, depending on what your policies are. It'll make sure, by the way, it puts you on a box that has available resources. It does all the stuff that a normal human being would do. Right? If there's a box that has nothing on it, it's going to put the container there versus one that has a bunch of resources on it because it assumes that you want the fastest box available. It's a good assumption. That's what I want. Right? If it has to choose between 5 systems and they're all the same resource level, but one of them has had your app before and therefore it's cached your image, it's going to choose that box. That's what I want. So just so you know, it's going to make intelligent decisions that like normal rational human beings would make to optimize the deployment of your applications. So ECS does this. So that's one option. And operating in almost the exact same way, but more industry standard, is EKS. Now, EKS is a little different, excuse me, because EKS does more than what ECS will do, and it is a CNCF certified distribution of Kubernetes, which means it is officially certified. It stays in compliance with both its current version number and its upstream version numbers. And most, like 90 something percentile of your tools are going to work on this Kubernetes distribution. The only reason I say that there's a few that you might have some struggles with is that Amazon does not give you full control over the primary nodes or the master nodes in this environment. So, you know, if you need to do weird things to the etcd database, they're not going to let you do that. So mileage may vary for some of the more risque open source tools, right? Otherwise, this operates just like ECS. Difference is that this is industry standard. So everything that everybody out there is doing with Kubernetes, the vast majority of it works great with EKS. Plus, here's the cool thing. Setting up Kubernetes by yourself is the hardest way to run Kubernetes. It can be fun if you love that kind of thing, but if you run this in production and you don't use a managed service like EKS, GKE, or AKS, you're going to lose weeks of your life learning how to troubleshoot this thing and how to keep it up and how to keep it running until you get good at it, and then it won't take as long, right? Notice, by the way, that you have Fargate options and you have EC2 options. So just like ECS, same thing. This runs pods, right? And so it uses workload types like deployments, stateful sets, deployments, cron jobs, batch jobs, and daemon sets. So, and all the standard industry tooling will connect into Kubernetes. Everything in Kubernetes is an API, just like everything in AWS is an API. So as long as you can talk to the API, you can do what you want to with Kubernetes. Now, Kubernetes' architecture is a little bit more transparent because it's not proprietary. So you do have an API server, you have a scheduler, you have a controller manager, you have a database called etcd. You also have a cloud controller manager, which is not listed here. I'm not sure why, actually. And so you have a control plane that monitors the cluster. Its job is to schedule, make sure all the applications stay healthy. And then you have what's called a data plane, which has an unknown number of workers. Out of the box, Kubernetes will support 5,000 worker nodes, but your mileage on it per cloud provider is going to vary. I don't remember what AWS's max is off the top of my head. I want to say it's like 3,200 per cluster, but again, numbers and lies. So remember that the real answer is I don't remember. But it's up there. It's like thousands of boxes. Notice that the container listed in black there runs inside of a deployment unit called a pod. We could spend 3 days talking about Kubernetes architecture alone, right? But just know that the pod is the thing that gets moved around and deployed. So the pod encapsulates the container, and that's what Kubernetes does to manage containers. Typically inside every pod is one and only one application container. You would not stick like your WordPress web server and your MySQL server, MySQL database in the same pod. Even though you could, technically you can, it is bad practice to do that. But what you might have is you might have an application container, and then you might have a security scanning container, and you might have an operational logging container, and you might have some other kind of operational container, and they are all stacked around this application container, making sure it's solid, secure, all its logs are captured, that it's monitored properly. So inside the pod, just be aware, you usually have one application container, but you could have a bunch of like enabling containers if you wanted to. That's usually best practice. Now, remember that both ECS and EKS have a Fargate launch type where you could just launch a container that's sized for your container, but you don't have to manage any servers. This is the one that I think I was misremembering might have grown to like 30 gigs in size as far as memory footprint goes. But again, numbers. I know it supports at least 10, but I think it actually has grown up to 30. I need to look up the documentation for this. These containers, there are other limitations for Fargate. Like it's not a free for all in terms of like what you can run. But it's a pretty solid offering. And I will tell you that if you get a chance to run serverless versus like running it on EC2, serverless is going to be way more cost effective. Consider this. Just think about this for a second. Someone comes to you, you design a Kubernetes cluster, and it doesn't matter if it's ECS, you know, if it's Amazon's proprietary cluster or whether it's actual EKS, right? But you start some kind of containerization cluster, and you've got 5 worker nodes. And each of those worker nodes has 8 processors and let's say 32 gigs of RAM because you're doing a 1-to-4 ratio. So you got 5 of them, right? You got 5 virtual machines just sitting there ready to take containers. In an ideal world, you would stack those systems up to 80% utilization across all levels. 80% CPU, 80% memory footprint, 80% network utilization. You would maximize your ROI that you're getting by running those 5 boxes. And if you need more horsepower, you just add a 6th. And if you need more horsepower, you add a 7th, but only after the entire cluster is about 80% utilized. In reality, here's what happens instead. You have a 5-node cluster. You're running, 500 containers. And those 500 containers are eating 80 or 90% of those 160 gigs of memory across all 5 boxes, right? Because remember, there were 5 boxes, they had 32 gigs apiece, right? So you got 160 gigs of total memory. Those containers are now eating, let's say 140 gigs of memory. So you've only got a little bit left on each box. Meanwhile, they're doing nothing with the CPU. You're doing nothing with the network cards. I mean, there's network traffic and there's CPU processing, but you can't add any more containers because you don't have any memory footprint. But you're still paying for these 5 or 6 boxes. And now you're paying for a 6th one. Now you're paying for a 7th one. Now you're paying for an 8th one. But you're really just maximizing on memory, right? Then you got to go back in and assess, do they actually need that memory footprint? What are they paying for, et cetera, et cetera, et cetera. Because you're paying for an 8 processor, 32 gig of RAM box. Instead, imagine where you were running 500 containers, but each container is running in its own isolated hardware space. That's what Fargate is. Its own isolated hardware space. Think of it as like little micro virtual machines, because that's actually what they are. So if someone comes to you and says, look, I want to run a container and I need 2 gigs of RAM and 2 processors. Fargate starts a tiny virtual machine that has 2 gigs of RAM and 2 processors plus 256 megs. So it can manage it. And it starts this tiny little virtual machine, and that's where your container lives. And the only thing you're paying for is the 2 gigs and the 2 processors. Think about how efficient that is when all you're paying for is exactly what you need instead of having to blanket request large chunks of capacity and you're not using it to 100%, right? Now you still might run into a memory problem, right? But now you're not getting any waste where you've got like 20 or 30 or 40 or 50 gigs. You got 10% of the box, 20% of the box, 30% of the box sitting there idle because it's choking on CPU or it's choking on memory or it's choking on networking, right? Now you've got a very efficient system where with Fargate, you're only paying for the container size that you need to run the container. You're not paying for large chunks of capacity to run these containers. Let me be clear, there's nothing wrong with that. Compared to virtual machines, it's way more efficient. But Fargate takes that efficiency and runs it to the next level. So if you get a chance, look at look at running Fargate for your workloads instead of running EC2 as your launch type. I think you'll find that the efficiency in terms of both performance and in cost is going to be way better. All right, so we got 2 options for production services, ECS, EKS. They both have EC2 launch types. They both have Fargate launch types. Been pretty clear about, hey, you probably want to use Fargate if possible. And so now our computational model makes a whole lot more sense, doesn't it? Because we've seen lambdas. Well, not really. We're going to get to that. But we've got the general idea. But now we've seen EC2. We've now seen ECS and EKS with EC2. We've now seen ECS and EKS with Fargate. There's far less to manage with Fargate, and there's even less to manage with lambdas. Before we go into our knowledge check, does anyone have any questions at all about ECS, EKS, containerization, microservices? Cool. All right, knowledge check. Which of the following are characteristics of microservices? Good, okay. So it looks like A and C was the most popular answer. That makes sense, right? Certainly not tightly coupled or tightly integrated. That's a no. And redundant. I don't think that even makes any sense, but okay, fair enough. You got it right. Although I see that some of you are afraid of commitment. So feel free to commit fully. All right, which of the following are characteristics of containers? Okay. So portable and scalable, hopefully we definitely emphasize that one. Remember, containers don't require a hypervisor. They do require a kernel. It could be a hypervisor actually, if it supports it. Like VMware's hypervisor actually does support running containers natively on it, but that's a rarity. Most hypervisors don't support that, so that's an aberration. Automatic, I'm not sure what that means. Repeatable though is a clear attribute of containers, right? Portable, scalable, and repeatable. Okay. Containers in Amazon ECS are logically organized on a set of machines called a what? Good. Notice that I added a set of machines called a what? Because I'm not sure where they were headed with that. But honestly, the concept is a cluster, right? A cluster is nothing more than a set of machines with a common purpose. If it's a database cluster, its purpose is to host a database. If it's a container orchestration cluster, its job is to orchestrate containers. That's all it is. Which of the following are components of Kubernetes architecture? I actually had my son the other day when I was talking about this with somebody else. He actually referenced a show that I know for a fact he's never seen because he's 14 years old, called Fantasy Island. And the guy on there, every time the passengers would come in, he would say, "The plane, the plane, the plane." So hopefully that gives you an idea. And I think most of you got the answer there. Data plane and control plane. By the way, which one is the plane where all the work is done, where the actual containers are hosted? Someone, which one is that? Yeah, so data plane. Data plane's where all the workers are. That's where all the containers are hosted. That's where all the work is actually done. Good. Why would you select to deploy your containers to Fargate over EC2? Huh. Because what happens when you add abstraction layers, right? there's something that you lose. You lose something when you add abstraction layer. So why would you add another abstraction layer? Why would you give this piece to Amazon? What are they going to do for you? Right? Well, you don't have to you don't have to patch your systems anymore. Just let Amazon handle it. They'll patch your system. They'll take care of it. But it's certainly not to take control, because when you introduce abstraction, you reduce control. When you introduce abstraction, you typically reduce management. You might increase flexibility, but you reduce your ability to manage and control to a certain degree. And optimizing price for a large load, if you have a super large container, it may not fit into Fargate. So may not be a good fit. Okay. Any questions about containers, orchestration, anything? Anything we've covered thus far?
I have a question about EKS. Does the EKS cluster or the EKS nodes, are they always, or are they by default an auto scaling group?
Are the EKS nodes by default an auto scaling group? No,
But I can make it so.
you can.
Okay.
Yeah, you can easily. Yes, but by default they're not. That reminded me, Rakesh, when you said that. And there was a Fargate. There was a set of Fargate limitations. Oof. I'm going to have to dig this up when we get to the lab. I wanted to like just spout off the mins and maxes really quick, but I can't remember what it is. Anyway, here's my suggestion is that I'd like to do a little quiz review with you, but I'd like to take a short break, because what we're going to do is I'm going to do a quick exam cram review with you. We're going to cover the next section, which is actually going to be on networking. And if memory serves, we're going to do networking, and then we can hop into serverless. So, and we might even actually do the serverless lab today, which wouldn't be horrible. But I was hoping we could take just a short break just for a little bit, just get brains fresh before we go back through and do the exam prep. So let's say it's 3:10 right now. Why don't we come back at 3:20 Eastern, so 2:20 Central. So let's come back in about 12 minutes, and then we'll take another break later when we before we roll into the serverless portion. Okay, I'll put a timer up, so let's be back in about 12 minutes. So with VPC endpoints in particular, this is really more of a security play than anything. With peering and transit gateway, this is really all about network routing and control, which has some security implications to it. And then hybrid networking in Route 53 is really just availability. Like, how do we make things work from our corporate to AWS, and from AWS to corporate, or even our edge locations. So endpoints first. Okay, without an endpoint, right? If you have something in a private subnet that wants to talk to like DynamoDB or S3, which is actually in another data center, these are public APIs, right? You got to put down a NAT gateway. You're like, well, Michael, I don't need this to go out to the internet at all. The only reason I'm doing that is because I have to, because your services are outside on the internet. Well, this is where getting into VPC endpoints is necessary, right? So with a VPC endpoint, what ends up happening is that instead of going out to the internet, going out the internet gateway, and then hitting the service, you just go through Amazon's backbone. They give you a little portal. It's almost like a little network card. You hit that, and that takes you over to the service in question. Now, these endpoints are virtual devices. So just like everything else, they look like a single point of failure. They're not. But the other thing to the catch here is that these VPC endpoints, you have to define one for every service you want to use. So you want to talk to systems manager privately, you got to define an interface endpoint. You want to talk to S3, it's a gateway endpoint. You want to talk to DynamoDB, it's a gateway endpoint. As a general rule of thumb, it's really easy to remember when you use gateway and when you use interface. Here's the deal. Gateways are old, and I don't mean that derogatorily. They've been around for a while, and they only support S3 and DynamoDB. That's the only services a gateway endpoint, VPC endpoint supports. Every other service out there, whether it's systems manager or whatnot, is going to be an interface endpoint. Everything else is an interface endpoint. There's also one other little gotcha. Interface endpoints are newer. And here's the weird thing. They are going to take an IP address from your network stack. So I do have like architect friends who create an entire VPC with subnets in it just for the interface endpoints. And everybody's going to go talk to that VPC if they want to get access to that endpoint. Now they use Transit Gateway to make that happen. It's not that hard. But I just want you to know, some people get irritated. They're like, I'm sorry, you're going to take an IP address off my range and I'm already, choked out on IP addresses. So just know that interface endpoints do take an IP address off your range. But so you might want to stick them in a shared services VPC and just make it available as you see fit, right? Okay. So here's a little diagram with a VPC endpoint. Whew, what an eye chart. Let's peel this back a little bit. Okay. All right, so I got a private subnet. We got an instance right here. Notice the route table on the private subnet. We've got an S3 prefix list. We've got a DynamoDB prefix list. Remember, gateway endpoints are older. They do not take an IP address off of your subnet. So the way this older technology worked is that at the VPC boundary, they put basically a little network portal. How did you find that portal? Well, there's a little code that you can see here that turned it on. I have no idea IP-wise what's going on underneath there. But as you can imagine, it's not taking an IP address. So what would happen is that when instance C wanted to go get to this S3 bucket, if it was using these DNS names, it would go through here. So if that's clear, if it's using those DNS names, it's just going to go through these endpoints. That's the way gateway endpoints work. Notice that this doesn't have any NAT gateway or any internet gateway in there, right? Now, what about interface? So interface endpoints are a little different. They don't sit at the VPC boundary. Instead, what ends up happening is that if you're on a private subnet, what's going to happen is that you're going to hit this IP address in order to get to Systems Manager. So this is powered by a service called Private Link. Private Link, by the way, just allows you to throw a network card anywhere, and it can be a portal into other VPCs or to other accounts if you want it to be. Right? So, in this particular case, ssm.usc.amazonaws.com, that DNS name for Systems Manager, instead of actually going out to the internet, instead what ends up happening is it's going to get redirected to this private endpoint. So like DNS automatically gets changed when you enable this inside of the VPC. So DNS now resolves to this IP address, because even your public instance is now going to come down here and talk to this instance. So you don't need to you don't need to hit it by IP address. You just use the normal DNS names that you would normally use by default to access Systems Manager. And you're like, well, Michael, I'm not specifying any DNS names. Don't worry about it. It's already in the base configuration for the agent. So it's just going to automatically work. So, because for example, if instance A has a Systems Manager agent on it, it's already geared to resolve Systems Manager using ssm.useast1.amazonaws.com. It's already hard coded to do that. So that's why this works. So once you turn this on, it's actually pretty automated. But just know that it is going to take an IP address off your range. Instead, like I said, I have friends who create VPCs and they like turn on, like it into a shared services, and they have like it redirect over to the VPC in question. So that way it doesn't eat an IP address in every single VPC. I've been trying to get them to actually do a reInvent talk on it because it'd be fun. So reminder, gateway is only for S3 and DynamoDB. Interface is for everything else. Now this is all powered by Private Link, which basically says, what if we took your instance, we gave you a private link interface, and it actually went to a shared application to an NLB over here. By the way, this is how service providers like Databricks and others are offering services to other people. So this doesn't have to necessarily be an account you control. Someone could grant you access to this if you accept it. You have to accept it. You can't just be given it. And you can get access to third-party applications as well. This can be done by, AWS partners like Databricks. Here, with Private Link, you could have a direct connector VPN connection into the VPC, which hits an interface endpoint, which then hits the S3 bucket. That traffic never goes across the internet, other than its encryption if you're using VPN, right? Because that is actually across the internet. So just know, you can keep everything privatized so no one has to go across the internet. So those are VPC endpoints, all powered by this networking portal technology that Amazon made up called Private Link, right? And just think of it as that they're just taking network cards and creating all kinds of cross-cutting connections. Those, by the way, all have their own security permissions assigned to them as well, that are independent of any firewall or anything else that's wrapped around them. They have their own security permissions. Okay. Next question that we want to ask, if we want VPCs to talk to each other, even if they're in different accounts, how do we make that happen? This is where VPC peering comes in. Now, we've seen this before, because you're going to be talking about private IP addresses. You cannot have the private IPs overlap, otherwise routing will not function. So you can't have a 10.1 and a 10.1 both trying to talk to each other. That's not going to work. They're not going to be able to self-identify. Well, they're not going to be able to other identify, actually. And just because you've got two systems connected to the same VPC, there's no pass-through. There's no they call that transitive peering. There's no transitive peering. And by the way, the VPCs do not have to be in the same account. They don't even have to be an account that you own. You can like offer to connect somebody to your VPC, and they have to accept. So it's a two-way handshake, right? This, by the way, will work across regions. So you could hook up your VPC in Northern California with a VPC in Jakarta if you wanted to. Watch out for latency if you do that. Now, when you peer it, by the way, notice that the route tables do change. So I'm over here at 10.1 and I want to talk to 10.2. Notice that my route table says, if you want to talk to 10.2, I need you to talk to PCX. So technically you're actually going to go talk to this guy, who is then going to redirect you over to 2. We do that whole thing in reverse. 2 wants to talk to 1. It says, oh, well, my route table says I got to go talk to this guy. So I'm going to go talk to him. Now we're talking to this. You can only have one VPC peering connection between the same 2 VPCs. There's a limit. I want to say it's like, could be a couple hundred, might be closer to 1,000. There's a limit to the number of like active VPC to VPC connections you can have in a single region. And managing this is a big headache, especially if you do a mesh model, right? Most people instead will do kind of a hub and spoke model where this is like the center, and these guys are connected together, and these guys are connected together, and these guys are connected. They're all centering on this, right? So this is like a VPC peering for shared services. So this is just an example architecture that you could use. Here's a full mesh. Oh, that's so much fun. So notice, like if we just pick on one of these, A, it has a connection with D, C, E, and B. So, yeah, this could be a lot. So this was the legacy way of doing things. In response to this, Amazon decided, you know what, let's come out with something a little bit more route oriented instead of our proprietary thing. So they came out with something called the transit gateway. Because without the transit gateway, managing all of your external edge and data center connections back to all of these VPCs, plus the VPC peering, is a nightmare. Let me offer you this perspective. If you take 6 VPCs and you mesh them together, it requires 15 peering connections to get them to talk to each other. That just starts to go way up, right? When you start adding 7, 8, 9, tons of fun. So like in this particular case, you've got, 6, 1, 2, 3, 4, 5, 6. You got 6 VPN connections, 6 direct connect connections, all going to, basically 6 VIFs with redundancy, right? So you've got 6 VPNs, you've got a bunch of direct connect connections, 15 peering connections, right? Between the 6. With the transit gateway, instead of doing this, which is thickly meshed, with the transit gateway, it starts to look like this. Everybody just goes into the transit gateway. It is the centralized transit hub. And the transit gateway basically manages the attachments between who can talk to who and how they get there. Oh, actually, it says it, attachment based. Yeah. So it basically allows you to segment and route based on whatever rules you want to specify. So this is on a private network, by the way. It's not exposed to the internet. And to say this, transit gateways can route to other transit gateways in other regions. So this allows you to route between regions as well, which is, kind of nice. So if you want to terminate your VPN, you want to, terminate your direct connect connections, you want to route between a bunch of different VPCs, you want to do a hub and spoke model, you want to do a full mesh model, you want to do a slightly mix of the two, all of that is possible. This is a layer 3 transit gateway router, right? So it will do IPv4 and IPv6, no issue. So it basically acts as a hub for all traffic flow. And by the way, it will support, because it's an IP, it's a layer 3 route, it will support multicast. It'll support low-level IP protocols. Here's some components. It has attachments, which basically says, I'm going to attach this VPC to this route table, attach this VPN connection to this route table. Direct connect goes to this route table. I'm going to attach this other transit gateway to this route table, right? So you get to control the routing. Each attachment is associated with exactly one route table, but each route table, by the way, could have many attachments to it. So you get to control exactly how things are routed in your environment using Transit Gateway. By the way, yeah, here's the Transit Gateway. Here's all the attachments. Obviously, there's route tables in there, as I just mentioned. Here, you've got a full connectivity model where everybody can talk to everybody else. All the VPCs can talk to each other, no issue. You can set it up so there's only partial connectivity. So like A and C can talk to each other, but they can't talk with B and D. Set that up if you want to. You could set up full isolation. So here, none of the VPCs can talk to each other, but they can all be accessed through the VPN connection at the bottom. So the world is your oyster. You get to configure this as you see fit.
This sort of example, so does the transit gateway hold the private subnets and like VPC B can talk to VPC A through that, or is it doing like, is that like a route exchange, or is the transit gateway doing some sort of like NAT and changing the addresses to get to it?
First of all, Kyle, I just have to laugh because you scared me to death for some reason. I wasn't expecting anybody to talk, which is totally fine. You should be talking. I think it's just been a minute since I heard anybody, and I was like, oh my God. So the question is totally legit. Here's the way it works: is that it's just a routing table, right? So all it's doing is, since VPC, that whole VPC, when it's looking for other networks, instead of like going directly to other VPCs, it's being told, hey, if you're trying to get anywhere, you're going to go to the transit gateway. And then when it receives those connections, when that traffic comes in, it evaluates it against the routes that are there for that VPC. And it says, hey, you're allowed to talk to D, but you can't talk to A and C. So at the time the traffic comes in, it's evaluated against the route table rules that are associated for that traffic. So it is actually receiving traffic and then evaluating its route tables to say what it can do. So it's really just like a pure router, really.
Yeah, got it. Okay. Yeah, that's like exactly just like a default gateway, and then it does the routing.
Yeah. I kind of make fun of them. It's like, it really took you that long to make this product? It's just a router. They're laughing. They're like, yeah, you do that at enterprise scale. I was like, fair enough. Fair enough. Yeah, that's all it is. It's just doing routing. It's not doing like any filtering or, payload and examination or its detection. It's not doing any of that. It's really just literally just evaluating traffic source and destination against its routing tables. And that's it. So transit gateway is another one of those things that doesn't have, there's no labs on transit gateway. I do remember, actually, hold on. I'm going to show you because I think you can just find this yourself. I think there was a transit gateway lab for the longest time. What was it called? Oh, it was part of the networking workshop. So yeah. Okay. And I think actually, anyway, paste this out there. That networking workshop, by the way, is just in general is fun. Sometimes these workshops are slightly out of date, but when you see new stuff like Transit Gateway in there, they're being maintained. Usually you just check the date down here. If this said 2019 or 2020, it's been a while since somebody looked at it. It's 2022, obviously, so this might be slightly concerning, but at least someone's looked at it in the last year. So just check the copyright date on your thing. If it's on the labs that I share with you, if they're older than like a year or two, they might not work. So All right, so that's transit gateway and VPC peering. Now, again, kind of like the way ECS and EKS, the discussion went, if you just want to set something up quick and simply, and it's just you and you just got a few VPCs, probably just use VPC peering. The minute you start throwing direct connect and VPN in there, and you need to start doing intra-region stuff and things start getting complex, and you're doing it for a large enterprise, don't even touch VPC peering. Just go straight for transit gateway. Trust me, you're gonna save yourself a lot of headache. Don't touch VPC peering if you're gonna do more than like 10 VPCs. So, okay. Next question. How do we minimize latency between our remote sites and, AWS? Okay, so, well, first of all, AWS has obviously site-to-site VPN connections. It's like 2 endpoints. It's like 2 VPN tunnels that, run from the customer gateway device over to the virtual private gateway, right? So, I will tell you that the VPN tunnels terminate like in different availability zones in the VPC. So I don't remember what the maximum like speed is. I want to say it's like 1.2 like gigabits or something like that, depending on what your pipes are. Obviously, your pipe to the internet is going to be your constraint, but I think it supports 1.2 gigabits as the max like total connection for the pair. It does use IKE, like IKE2 or something for the exchange. If you're wanting to use something else like GRE or whatever, it's not going to work. So you need to roll your own VPN at that point instead of using the VPN service. If you're going to get that specific. To terminate that VPN connection, you could actually terminate it against the VPG, which is the virtual private gateway. You could terminate it against an EC2 instance, or you could terminate it against a transit gateway. Obviously, I'm going to tell you to terminate it against a transit gateway if you need a transit gateway. If you're doing multiple connections, like dozens of connections, if you're just doing 1 or 2 connections, you can still do a transit gateway if you wanted full control over routing, or you could just stick with a VPG. That's fine too. But if you got the stomach for it, I probably just would stick with a transit gateway. You never know what the future holds for our IT infrastructure. So it's a lot more flexible if you just go ahead and start with a transit gateway. Terminating it into an EC2 instance is a really bad option. Only do that if you're running that EC2 instance, like if you're running like a Cisco device or some other kind of like proxy on it. And that means you're probably doing something weird with networking and you want full control. Otherwise, do not terminate into an EC2 instance. That's it's going to be fraught with peril, to borrow a phrase. So that's VPN. And again, you do need a device on your end. But like, I bought a device the other day for $40 that will allow me to do site-to-site VPN into AWS. So it's not like they're expensive. Now, a corporate one obviously might be a little bit more expensive. And then you can always run a physical cable from your data center to one of the partner locations, who in turn will run a cable for you over to AWS. So just know that you can always just, use direct connect. This comes in like sub gigabit, 1 gigabit, 10 gigabit, and 100 gigabit flavors. You will terminate against a virtual private interface. So this data, by the way, is not encrypted. If you want to encrypt it, you could run a VPN through it. Or I think you can do something called MACsec. Yeah, I think you can do MACsec in order to do an encryption against the data. A lot of people I know just run VPNs inside their tunnels. Here, by the way, when you run your own cable from AWS to your data center, you get very predictable network performance. You're not subject to internet weather at this point in time, right? So, and like I said, it runs straight into your VPC. You will want to hook that into a transit gateway, most likely. And these like public virtual interfaces will allow you to talk to like public services like S3 and DynamoDB. You can also just run everything private and then just use VPC endpoints to route that private traffic into public services. So, you know, there's a lot of different ways to kind of like solve any architectural problems here for the networking pieces. Here's one option, right? Where you're using a private VIF to access like private IP addresses. Again, if you still need access to public services, you can use private link. You can use VPC endpoints for that. Here's another option where you're doing a direct connection and you're going from a private VIF to, instead of a virtual private gateway, what's happening is that you're going from a private VIF to a direct connect gateway. So you can actually terminate direct connect from the customer either with a virtual private gateway, you can terminate it with a direct connect gateway, and the last one is you can terminate it with a transit gateway. Now, you know what I'm going to tell you. Just go ahead and terminate it with a transit gateway, because it's going to give you future flexibility that you won't have with a direct connect gateway or a virtual private gateway. But again, if you're like in a hurry and you don't want to set up a transit gateway, which will just take a little bit longer to set up, then go with the virtual private gateway. If you take the professional, the advanced architecting on AWS class, they go into a lot more detail on this. They are not going to ask you deep questions about this on the associate's level exam. Just know, by the way, that you can connect up to 3 transit gateways over a private dedicated connection using what they call a transit VIF, which is just a virtual interface to a transit gateway. So, okay. Last but not least, so we just talked about hybrid networking. We talked about direct connect, VPN, transit gateways, VPC peering, right? Talked about VPC endpoints, both gateway and interface endpoints. Now we're going to talk about DNS. Okay, so this one's kind of cool because Route 53 as a service basically allows you to route connections both publicly and privately, but mainly publicly, to healthy instances. And there's a number of DNS policies, like routing policies, that you can apply to DNS. You can do obviously public hosted zones, which are things that you want to resolve publicly, and obviously things that you want to resolve privately, right? That you want to do like inside the VPC, that's a private hosted zone. If you want to define how traffic is resolved on the internet, that's a public hosted zone, meaning anybody can read that one. But for the private hosted zone, you got to be on the network in question for it to resolve that way, right? So public hosted zones are really for like public facing resources. Private hosted zones are for, private internal resources. Now, if you're doing public hosted zones and you want to control how traffic is routed, Route 53 actually integrates really well with AWS infrastructure. And there's a couple of policies you can look at. Obviously, there's a simple policy that says, look, if you go to this site, if you go to example.com, just go over to this IP address. But you can do failover. If you want to hook into 2 load balancers, one in US East 1 and one in US West 2, and if US West 2 goes down, you want to route all traffic to the other one, you can do that. It will literally, by the way, talk to the load balancer to make sure that the instances are healthy. So you can create your own health check, or you can use the load balancer's health checks, which, by the way, is not a bad idea. You can also route based on location. Say, look, if you're in Europe, I need you to go over to Germany. If you're in the United States, I need you to go to Virginia. So there's geolocation routing. There's geo proximity. It says, look, whoever you're closer to, I don't even care what continent you're on. If you're in Spain and you're closer to Milan, as an example, like you're closer to Italy than you are to Ireland, then go to Italy. Right? So it basically allows you to bias the connection based on geographical proximity. You can control this, by the way, by increasing the bias of a region. You can say, look, I want everybody to go to Germany except for these fringe cases, right? You can do that. You also do latency based, which is not about proximity. It says, who's the fastest? Right? Who is the fastest? This 76 millisecond latency, I want that guy. Right? So there's a couple of like cool routing policies that you can do for this. There's also a multi-value answer where you're like, hey, I'm going to return 5 servers. I'm going to give you the healthy one every time. So, you know, I believe it does round robin on that on purpose, but it's only going to return the values of healthy resources. And then you can do weighted routing. So if you want to do like A/B testing, or you're like, I want 90% of my people to go to Virginia and I want 10% to go over to Oregon, as an example. You can do blue-green, you can do A/B testing. This will allow you to flip over. Beanstalk, Elastic Beanstalk uses DNS to do this when you do a blue-green deployment. It's like, hey, 100% was all in blue. Now we're flipping over to green, right? So just know that there's a bunch of like routing policies that DNS can use, which are kind of nice to have. Oh, yeah. So when you create a VPC, by the way, just as a side note, if you want to seamlessly resolve from your VPC resources to corporate resources and corporate resources and vice versa, you can actually set a DNS resolver inbound endpoint and a DNS resolver outbound endpoint. Meaning, like, if people are going to go outside of your network, you can say, I want you to talk to this machine. And if people are coming to inside your network, they're coming inbound, you can say, look, I want you to resolve this way. So that way, if the corporate network is trying to resolve internal AWS resources, it knows to hit the inbound. And if your AWS resources are trying to resolve off-premise resources, they can hit the outbound in order to do that. And you can forward that to the associated DNS servers. So for example, you can make sure that for outbound is actually talking to your DNS server on your corporate network. That way you can make sure that the resolution is seamless and you're not having to maintain records in like 15 different places. I know, it's a lot. Okay, let's do a little knowledge check. All right, what is the network attachment? Man, you know what? Just gave that away, didn't I? What's the network connection to a transit gateway called? A network attachment. We're just gonna move on. All right. kind of softballed that one up there, didn't I? What are the components of an AWS site-to-site VPN connection? So tell me what you need on the customer side and tell me what you could have on the AWS side. What do you need for this? All right, so looks like a customer gateway device. Looks like one option. And then what's the other thing we need on the AWS side? Well, first of all, if I talk about VPC endpoints, what are the two things that are VPC endpoints? Right? It's B and E, right? So those should be off the table, right? B and E are off the table because those are VPC endpoints, not anything to do with the VPN, right? Those are VPC endpoints. So a VPC peering connection is for peer-to-peer. So if I were to take a swag, it's probably A and C, which I think some of you figured out as well, right? A customer gateway device, and then you need a virtual private gateway in order for that to terminate. Transit gateway could have been an option here as well. Okay. What of the following is true regarding VPC peering connections? Okay. Well, connections require a transit gateway. We know that's not true because remember, there's the old way and the new way of doing it. So you could actually just have direct connections. Connections can span accounts. I think that's something that we pointed out, right? Connections are transitive. I was very clear they are not transitive, right? So it looks like B and D are going to be the answers there because they are one-to-one. So every single connection has to be set up one connection at a time. You can't set up multiples at a time. You got to set them up one at a time. And then the connections can span accounts. The rest of this is false. Okay. How can an application running in a VPC access S3 without internet access? What can we do for this?
Michael, you muted again.
That's what happens when the boom mic goes up. Here, I was trying to prevent everyone from hearing me swallow. So gateway and interface endpoints are the two VPC endpoints, right? They're the two types. Gateway is the one that has S3 and DynamoDB. Interface has everybody else. And that is the end of module 10. Questions around anything related to this kind of like hybrid networking that we just talked about? Yeah. Okay. Here's what we're going to do next is that we're going to talk about serverless, and that's going to be the last topic we cover today. So thank you for sticking with me because I know it's been a little bit lecture heavy this afternoon. We're going to pick up the lab in the morning, first thing, and then we're going to talk about some edge services like CloudFront and whatnot, and then Global Accelerator. We'll talk about that as well. Then we'll do another lab. And then we're going to talk about backup and recovery. Probably we'll take lunch at that point in time. And when you come back, I'll talk about training, and then we're going to end it with a capstone lab. Now, before I talk about any of that, just as a little side note, I'm not sure what the thinking was with this, but AWS is going to basically have us in a site called Skill Builder, which may be important for you to know because your supplemental material for this class is actually in Skill Builder as well. Now, it will require you to sign in using an Amazon account, but you could use your personal account. It doesn't really matter, honestly. Although, man, every once in a while, it just does these weird things. Let's try this again. Sometimes those captchas, man, I think they're hard for human beings to read.
That sounds like something a robot would say.
Indeed. Yeah, every once in a while, it's just like, hey, I want you to do a captcha. It's like, why? Because this website's relatively new, so it's a little buggy here and there, but it's improving rapidly. So where's that supplement? Architecting on AWS online course supplement. So I'm going to paste this in the chat. You definitely want to bookmark this. I just gotta forewarn you is that your last lab, the capstone lab, is not really in Quick Labs. I know that sounds strange, but I just want to take a minute to explain this because I'm going to explain it again tomorrow. Is that your last lab down here actually has no instructions for it. You can start it. It'll let you log in, but there's no instructions. So I just want you to be prepared for this, is that your last lab actually is not, the instructions are not on Quick Labs. The instructions are actually in that course supplement. And so the course supplement actually contains the instructions for the lab because there's 2 versions of this last final lab that we're going to do. And so if we go down to the very end, the capstone lab is at the very bottom. And, you know, this is where you're going to learn about the capstone lab, but you have to access Skill Builder in order for this to work. So when you get a chance, sometime between now and lunch tomorrow, please log into Skill Builder and make sure you can access that link because you're going to need it for the last lab that we do. Now, there's a couple of different versions of this lab. There's one version where you get very little instruction and you build stuff manually. And that's for people who have worked with AWS for at least a year, like in an account. If not, what you're going to do is you're actually going to go to the lab instructions section at the very bottom, and you're going to follow the lab instructions just like you would if you were taking it on Quick Labs. Because if you're not super familiar with AWS, then this lab will be super painful. If you are, then all the lab instructions are here. Step by step, it'll show you how to run like whatever you need to know how to run. So just know you have been forewarned that your last lab, all the instructions are going to be in Skill Builder at that link that I sent you. And I'll explain all this again tomorrow. I just want you to be kind of pre-warned for the discussion.
And that's us logging in with a personal account, correct?
Yeah, I mean, if you have an Amazon account that's for your business, you can. But most of us are going to log in with your own personal account. It doesn't matter. That all the training, by the way, that's on Skill Builder is free. So just to come out here for a second, you can actually pay for classroom training. But otherwise, if you're out here and you're like, you know what, Michael, I don't really know anything about CloudFront. Just know that AWS has published all the classes they have on CloudFront, including things like troubleshooting CloudFront or introduction to CloudFront. Notice that, by the way, that these are in different languages. One of the things I've asked them to do is please add a filter for languages. I love that they have a bunch of different languages, but you know, most of the time I'm either doing it in, you know, Spanish or English. And so I need to be able to filter that out. Right. So regardless, so just know that all this training is free. So, you know, it's not obviously it's not the same as instructor led, but if you need like a Skillshare, Linux Academy, Cloud Guru place where you can actually get access to training like this, you can find everything out here that you're looking for. If you're looking for VPC endpoints, you know, they'll give you an idea of like where you can find, right? It's probably inside one of these VPC courses, right? So they're going to talk about it there. So you can actually find tons of information. Everything's out here. So this is actually a good resource just for you to have in general. But do note that tomorrow our lab will take place in that supplemental material that we were looking at. So, oh, by the way, this is where the like gamified virtual reality game is. It can be run in a browser called Cloud Quest. So I don't know if any of you saw the news on that they published a game on how to learn AWS. Kind of cheesy, but fun nonetheless. Okay, I'll remind you tomorrow. But meanwhile, grab that link and make sure you can log in using your own AWS account. Otherwise, let's talk about serverless. Any questions about anything before we go forward? Okay. Okay, this is a good question, actually. What are you responsible for if you run your code on Lambda?
Writing the code.
That's it. You don't have to manage the servers. You're not going to patch the operating system. You have to worry about scaling. None of that's your business. All you do is write the code, answer a few questions about what's going to trigger the code. You're done. So serverless is really where we're at. This is the thing we're want to talk about. And serverless, again, is just functions as a service. It's not really like a full, like huge, like microservice code base. Although you can set up microservices in Lambda, you need to understand how event-driven architecture works to make that happen. I have to say, though, is that for resources that are not running 24/7, Lambda, just like any of the serverless options, is a great service to know. And every single hyperscale cloud provider has one, and they are awesome. So what if you don't want to deal with servers and you want to get out of that space and you have a microservices architecture that will support it? Using Lambda in conjunction with things like step functions and message queues and notification systems is excellent. It's a great way to run your app. It's also a very lean way to run your application. So how do you build an event-driven architecture? How do you connect applications to services? How can you send notifications and text messages and emails and other pushes? How do you stream large amounts of data? And if you want to run 50 Lambdas, how do you coordinate them with a state machine? So these are the things we're going to talk about. So here, by the way, is a completely serverless architecture, which does like an order and customer updates, and it supports everything from customer login to wish list syncing. Does that sound familiar? I wonder who might be using this actually in production live out there right now. Wonder if there might be any company doing that, right? Including authorizing payment, processing orders, sending the order to ship. I'm sure somebody's doing this. So what do we mean by serverless, right? Obviously, there's no infrastructure, so it just means hidden servers. You only pay for as long as the code runs for whatever it's doing. It automatically will just run multiple instances as the instances are invoked. You're only paying per millisecond. If it runs 300 milliseconds, you pay 300 milliseconds. That's it. There's no server, so you don't have to deal with any of the server management stuff. Now, AWS's serverless portfolio includes a number of integrated services, but the core is mainly Lambda and step functions. Those are the two cores. You throw API gateway in there and you've pretty much got the trifecta at that point. Now, SNS and SQS, AppSync, all these other services, they're useful add-ons. They are not required for serverless. Here in this serverless architecture, we're uploading an inventory file. It's going into an S3 bucket. That triggers an event notification, which causes Lambda to read the file and then stick the results in a DynamoDB table. Streams then triggers a table update, which triggers a notification, which tells the user. And then the user can then log in to the dashboard app and read the data. No servers, only services. So rolling this forward, we're going to talk about the services that could be used, particularly API Gateway and step functions are probably the two most important ones. The other three are nice to know, but they're not essential. SQS and SNS are way more important than Kinesis. Kinesis is just like Kafka. So for those of you who've ever touched Kafka, Kinesis was Amazon's answer to Kafka before Kafka got popular. It's just a streaming, I don't know what you call it, a streaming data bus, streaming data store, streaming service. So what about API Gateway? Well, API Gateway is like a load balancer for APIs. Now you can also use an application load balancer for this, but API Gateway has so many more features for APIs than an API Gateway does. So you can create an entry point, and API Gateway can point towards Lambda functions, APIs on ECS, APIs on EKS, APIs on EC2. You can point to your on-premise systems. It has a unified front end for APIs. It will do, metering, rate throttling. It'll do costing. So like if you want to do billing plans and whatnot, it'll do authentication. It'll basically monetize and manage your APIs for you. It does support RESTful or WebSocket APIs. Here's a gateway sample architecture. Note that in this case, it can send detailed metrics to CloudWatch. You can cache responses into a caching system if you want to. It'll integrate with CloudFront, and it'll talk to whatever number of Lambda functions you want on the back end. So you can write your own full-scale, huge API system if you want to, using the API Gateway as a center point. So just know that this service exists. There is, by the way, a whole class called Developing Serverless Solutions on AWS that deep dives into this really deeply. And if you take the professional level course for architecting, it also dives into this a lot deeply. Right now, just know that it exists. You need to know just a little bit about that. It does metering and rate limiting and throttling and all that other stuff. But that's really it. What about queues, by the way? What about messaging buses? Well, first of all, let me just tell you, just like there's ECS and EKS, Amazon has SQS. They also have a product called Amazon MQ, which is industry standard like RabbitMQ and ActiveMQ. So we're going to talk about the proprietary one, but I just want you to know that there is actually an industry standard service that they offer as well for like MQTT and AMQP. So if you need industry standard protocols, they have that. This is all API driven, but this is proprietary to AWS. SQS is a beast of a service. It's awesome. But there are like use cases where you're like, I really need to actually use an industry standard. So just know that Amazon MQ is out there. But the simple queuing service is a great service, fully managed, stores messages until they're processed at least once and then deleted, and basically acts as a trough, like a messaging bus. You just dump all your messages in there, and then you send the workers to come and pick out the messages and process them. This is great for asynchronous style engagement. So without SQS, you might have a bunch of web servers just dumping and overloading messages against the application tier. But if you throw SQS in there, now you've got basically an abstraction layer where you could dump 100,000 messages into this queue, and then the consumer tier can just pull messages out of the queue and process them as quickly as they can. You could even auto scale. So the SQS even has an auto scaling feature that will trigger the scale up of your backend processors based on the depth of the queue. So SQS is a really great product for this kind of asynchronous processing. And by the way, if there's a job that for whatever reason won't get processed, it'll kick it to that dead letter queue. So you just need to have a system go and check the dead letter queue every once in a while and say, hey, how come this thing can't get processed? It might require further troubleshooting, by the way, just FYI. So this is a great example of using asynchronous processing and some loose coupling to break the tight coupling between your customer tier and your producer tier. Sorry, your consumer tier and your producer tiers. So your web app and maybe your application app, right? Just put an abstraction layer in there. So this gives the consumer tier a little bit of breathing room, right? Now, SQS is great for like when you need work queues. And by the way, it can do standard work queues, which is just like kind of random order, or it can do very ordered first in, first out structured queues. You can use it for buffering. It will auto scale, right? You can just offload requests, especially if they're asynchronous. And there's two queue types. So there's standard and then FIFO. I will tell you that standard operates at like you can dump like hundreds of thousands of messages per second onto a standard queue. With a FIFO queue, I want to say you're only going to get about 300 messages per second max processed. But there's a big difference in that, a FIFO queue will guarantee it's only processed once and only once. A standard queue will guarantee that it's processed, but it's going to be like at least once. In other words, if there's a mistake and someone comes back and sees that the ticket is still in the queue because it took too long to process, you could have a second machine process the message, which would create a duplication. There are lots of ways to get around that, but just know that that's a possibility. So in addition to having standard and first in, first out queues, SQS also has like timeout visibility, like timeouts that you can add. You can long poll and short poll. You can have these dead letter queues where you dump stuff. And so what happens is that when a producer sends a message, unbeknownst to you, it gets replicated to some of these backend servers. And then what happens is that the consumer on the right-hand side is going to pick up the message, and the message is locked. It's called a visibility timeout for some period of time. The default, by the way, is 30 seconds. Maximum you can set it for is 12 hours. If after 30 seconds, no one comes back and deletes that message, it becomes visible again for some other consumer to process. Because remember, this queue guarantees that it's processed at least once. So if that computer dies, it's in the middle of processing it, the message is going to become visible again and somebody else can pick it up. So that way, no message is ever not processed. The worst thing that happens is it gets processed twice. If you read the message to process it, you are given a read receipt. And with that read receipt, you can actually delete the message. If you haven't read it, you can't delete it. Now, let's say that you are a consumer and you're like, hey, SQS, do you have any work for me? Now imagine you're in a room full of 9 people and you're talking to one of them and you say, hey, do you guys have any work for me? If you're doing short polling, it's like talking to a room full of kids. It's not even going to ask anybody else. It's going to say to the person next to it, hey, you got anything for him? You got any work for him? No. It's not going to talk to the room, right? That's what short polling is. where it only talks to like 3 or 4 servers and says, hey, I don't think we have any messages for you. With long polling, like an adult, it says, hold on, wait for a second. Hey, does anybody in this room have a message for this consumer? Talks to every server, and every server gives up every message it has. And the consumer's like, okay, yeah, I'll take that one, right? So long polling will wait for like to make sure that you can talk to all the servers. Short polling is only going to talk to a very small subset of the servers and say, hey, you got any messages? Yeah, these 5, these 3 guys have messages, but it won't talk to all the servers in the queue. So just know that long polling talks to all the servers, short polling doesn't. AWS recommends that you use long polling when you can, because short polling may have you missing messages. Don't worry, you'll pick them up eventually, but from a time perspective, right? Okay. So then we got the dead letter queue. The dead letter queue I mentioned before is like where things get dumped if they, for some reason, they can't be processed. You could, by the way, have that dead letter queue trigger a Lambda function to like try it again or try it a different way or try it with different parameters, or to just email somebody and say, man, this message has been here for like a day. Someone needs to go fix it. So you want to use message queues, by the way, when you're not doing a pub sub model. You want to make sure that something is processed at least once each and every time. It's asynchronous, so you're not like, they're not sitting there waiting. And these message queues, by the way, are limited to 256 kilobytes in size. So this is not for like super large messages. It's for tiny messages. Although 256 kilobytes of text is a lot of text. So, okay. Now, SQS is a poll model. You go to the queue and you ask if there's work. SQS has a sister service called SNS, which works off of a push model because it's a notification system. So before we go off of SQS, though, on to SNS, does anyone have any questions for me?
Nope.
Okay. So SNS is pub sub. You got a topic, people have subscribed to the topic. And so when the publisher publishes across the topic, it can go out to all the subscribers. Do know, by the way, that a subscriber can actually put filters on their subscription. So that's a relatively new feature, but a subscriber can go in and say, look, if topic doesn't equal Kubernetes, I don't want to hear about it. So if topic equals AWS or Ansible or Docker, it's like, you won't get it. Note that it can send email, it can send text messages, it can do mobile pushes, it can do HTTP posts, right? It can trigger Lambda, it can dump data onto Firehose, it can trigger a queue. Your subscribers could be a lot of other services, not just messages. This one is also limited to 256K messages, just like SQS, right? So, and the use cases here could be email lists, notification updates to users. You could push the CloudWatch and trigger a response, right? So basically you can like trigger any service. You mainly use SNS when you want a single message to be duplicated out to a bunch of targets. That's when you use SNS. SQS is for one message that you want one person or one service to process. So SNS does a single published message to each target. You cannot recall the message. If you do a web post, it will actually retry it. And just like SQS, you can actually do a standard or FIFO topic setup. So it can do it, deliver it in order, or it can deliver it at random. Now here, SNS is being used to fan out the message by, basically slipping from a single message coming in to now 2 messages being duplicated across the queue, and that message gets sent to 2 different processing systems. That's pretty standard. So when you compare SNS and SQS, by the way, note that SNS has no message persistence, although SQS can keep a message, I want to say for it's like up to 14 days, actually. It's not a database though. SNS is a pub sub model. And note that SNS is a one-to-many. One message gets copied several times, whereas SQS is simply just a one-to-one model. That's it. All right. So that's SNS and SQS, sister services, both capped at 256K message sizes. One is poll, one is push, one supports pub sub, the other one, supports like a, a pull model, right? But really used to either add some level of duplication or asynchronous reception, like an abstraction layer between services. Now, before we get to step functions, which is not a long conversation, it is worth just a notable mention that Kinesis is Amazon's streaming like data service. Now, they also have managed Kafka. So you might notice this trend that I keep kind of reaffirming to you is that Amazon will run their own proprietary stuff, and that's typically going to be cheaper, faster, leaner, but they'll also support industry standard tools like Kafka, Elasticsearch, that kind of thing. And so you can always get what you need, right? If you want something a little faster and proprietary and you're okay with that because you're greenfielding your application, use the native service. If you want something that's a little bit more portable, a little bit more industry standard, Amazon will offer that as well, right? So notice there's 4 different products here. There's Kinesis Data Streams, there's Kinesis Data Firehose, there's Kinesis Data Analytics, and there's Kinesis Video Streams. So each of these basically collect, process, and analyze data in real time. So this could be audio, this could be application logs, this could be video, like the video streams. It could be IoT telemetry data. It could be, clicks on a website. You don't have to wait. You don't have to wait for, by the way, for the data to be collected in its entirety for it to be processed. And so you can see what it supports down at the bottom. It's all listed there. So like, for example, if we were talking about data streams, one possible architecture that might make sense is you got people producing data and it's going into Kinesis data streams. And each shard, by the way, will support 1 megabyte of ingestion and 2 megabytes of, kind of downstream expression. So it's like you can receive 1 megabyte per second and you can read off the shard at 2 megabytes per second. You want to go faster? Add more shards. In other words, the data gets split among a larger number of like horses or engines, if you will. And so you can go faster just by splitting the data into a larger set of systems. Here, consumers, which is in that 3rd category right there, they're reading off of the shards that make up that particular Kinesis stream. And then the consumers are writing that data out either to Redshift, to S3, or DynamoDB. Now, notice there are consumers here, though, right? And that one of they could be a Lambda function. You don't know, right? But there's applications here that are reading these data streams and then dumping them into a database. Amazon also came up with Kinesis Data Firehose, which is where you are writing data into a stream, and that data is automatically being dumped into targets of your choice. In this case, it could be a third-party provider, it could be Redshift, it could be whatever. Now, note that we're not going to talk about data analytics. which is where you can add like, random cut forest and kind of other like, data reducing algorithms in, God, random cut forest is actually a unsupervised learning clustering algorithm, right? So it actually will tell you, it'll spot, aggregation patterns inside a set of data. So data analytics will actually allow you to run like analytics against data as it's streaming, which is really cool. Video streams will allow you to modify and change video streams as they're running, but you can also analyze them for sentiment analysis, audio, visual palettes, coloring, object identification. So you can do this in like real time. Well, we don't talk about that here. We just cover the first two, just FYI. Okay. So the main thing to know is that Kinesis is a streaming data platform. It's got 4 different flavors. And there is a managed Kafka service. It's called MSK, Managed Services for Kafka. Okay. All right, last one, and then we're going to be done for the day. Is step functions. So think about step functions as a Lambda orchestrator. It's a serverless orchestration system. So step functions allows you to basically run a state machine and walk through a customer workflow where you can either choose parallelized tasks. You can actually define a customer or some kind of application workflow or interaction, and step functions will do all the state checking for you. Did it pass? Did it fail? And it will coordinate the execution of all the Lambda functions to make it happen. So think of it as a state machine that has a set number of operating conditions determined by its previous outputs, right? So like, think of it like, like in the example, they talk about like a soda machine where it's like in a waiting state, it's operating, right? It's just cooling, everything's getting maintained. And then you go to put money in and it says, okay, choose your soda. So now you're in a selection state. Which soda do you want? After you choose, it then goes into a vending state where it's going to take the soda you asked for, put it down and make it available to you. And then maybe it's in a receipt printing state after that. With step functions, you can actually define all the different states using like JSON and what's called this states language. So what's the start state? Like what's the waiting state? What's the choosing state? What's the vending state? What's the receipt printing state? And all of those states can actually call code. And so you can build these cool workflows. Like this is an identity checker, right? Verify identity documents, check an address, doing a human review. Like you can actually put like tasks in there. You can put choices in there. You can put like weights in there. You can dynamically map it to another state. There's other options. So here's a complex distributed workflow. And so, these workflows are ideal for high volume event driven processing, such as like IoT ingestion, data processing, each of these express workflows, by the way, can run, if it's a Lambda function, obviously it'll run up to 15 minutes, right? And so that's what step functions does, is it orchestrates complex workflows using Lambda, has the kind of like task executor. But it doesn't have to be Lambda. It could talk to an API gateway. It could talk to DynamoDB. But Lambda typically is the orchestration kind of like workhorse for step functions. All right. Let's take a quick knowledge check. Which type of Amazon SQS queue provides at least once delivery? Good. You picked up on that. Perfect. Yeah, and FIFOs are good for if you want to make sure it's processed only once, right? All right. So what's an advantage of long polling compared to short polling? Remember my example of like short polling. Yeah, we don't have anything for you. Like, yeah, you do. You got 6 servers back there with messages, right? Versus long polling where it's like, no, I want you to talk to everybody. I'm gonna wait here. Another thing to mention is that when you do long polling and you go to do the poll, it'll be like, wait, wait, wait. I got messages for you. So you won't get an answer right away, right? So the answer in this case is going to be C, right? Because you're not going to get an answer right away. It's definitely not more stable when using a single thread to pull multiple queues. They actually recommend that you use a thread per queue, right? And long polling is not going to reduce cost per se by only sampling a subset of Amazon SQS servers. It reduces costs by reducing the empty number of times that you go and talk to the API, asking if there's anything there. Remember, you get charged for every API call. So let's take our time, make the API call and wait for an answer instead of, hey, do you have something for me? No. Do you have something for me? No. Do you have something for me? No. That's 3 calls when you could just be like, hey, do you have something for me? And it's like, wait, wait, wait. You know what? I do actually. Different thing. Okay, what's a feature of SNS?
You're muted.
Oh, yeah. So looks like you all answered C, right? You can take one message and publish it to many subscribers. So that's perfect. Okay. Let's see. One thing I was going to check, otherwise we're still going to be done, but I just wanted to check really quick. Is I don't know. We can cover this tomorrow. We're not going to do it today. I don't think so. SQS is in here, but I don't think SNS is in here. But it'll ask related questions. So here's what we're gonna do. Tomorrow, when you come in, the first thing that we're gonna do is we are going to do the lab for serverless. And so we're gonna work on lab 5 when you come tomorrow. And so this is where we're gonna build a serverless architecture. So I'll pre-warm it before you show up and make sure that it's ready to go. But we're gonna cover doing the serverless lab, and then we're going to talk about edge services, and we're going to do an edge lab. We're talking about backup and recovery, and then, like I said, we're going to do training afterwards, and then I'm going to basically kind of end the class, even though I'm going to be with you the entire time. But that way, you can finish the capstone lab and leave when you're done, instead of having to wait for all of us to gather at the end of 3 or 4 hours. And some of you, there are some people who will skip the capstone lab. I don't necessarily recommend that, especially if I'm available to support you, but there's no harm in that if you're like, I'm done, right? So just to make sure. You do have access to all of the labs at least 3 times. Sometimes you can get away with a 4th time, but I think you usually can run them 3 times for the next 6 months, okay? So for now, we're done. So we'll start with a lab in the morning. Please make sure you can log into Skill Builder. Test that, preferably before tomorrow morning, but if before lunch tomorrow. Otherwise, I'm going to hang out here in case anybody has any questions, but I am done with you. So unless you need anything from me, we are done for the day and we're going to pick it up tomorrow.
Cool. Thanks, Michael.
Thank you.